Okay. Okay. Hello, everyone. Good morning. I'm Bianca Howard. I'm an assistant professor in mechanical engineering at Columbia. And I'm going to talk to you today about some of the research that I do around building decarbonization for kind of two applications, one for planning and one for operations. I run the Building Energy Research Lab, and our main kind of focus is looking at using building physics and paired with optimization, machine learning, and AI to kind of solve questions that we have around how can we make our buildings more energy efficient and switch to low carbon fuels. So the motivation for this work, I kind of work in the urban space, so look at cities as a motivation. So in cities like New York, a majority of greenhouse gas emissions are attributed to buildings. That's the biggest piece of the pie there. Second to transportation. So if we're going to try to meet, climate change goals, we need to be addressing buildings. We have plans of how we're going to, reduce emissions by 2050, and building interventions are a big part of that plan. So, and that is interventions that needs to happen to existing buildings. So making them better insulated, so we reduce demand, and also kind of looking at electrification solutions for our heating system. So as a mechanical engineer, I look at it from the lens of heating and cooling and hot water services, ventilation, those energy demands, which are a large portion of energy demands in buildings. But this comes with some challenges. When we talk about electrifying buildings, so switching from using natural gas to heat up water to using electric-based sources, we could potentially double the peak demand on the electricity grid. So there needs to be some management of how we're dealing with the peak demands. That can be done with reducing demand through energy efficiency, or also making intelligent buildings that allow you to shift demand in response to grid signals. Buildings are also where people live. And so there's kind of these additional elements that we need to consider. So in New York, they're projecting that there's going to be an increase in the number of days above 90 degrees Fahrenheit or 32 degrees Celsius. So there's questions around, how long can our buildings stay cool? What does that mean for electricity demand? What does that mean for vulnerable populations? And as well as, extreme heat, there's also air quality questions. And in New York, about 50% of PM 2.5 comes from combustion in buildings. So with building decarbonization, we can also potentially address air quality as well. And in New York, we have a housing affordability crisis. So when we talk about building decarbonization, we're also talking about potentially increasing the cost of living, because how are we going to pay for all of these different interventions? And then this space also is operating in a regulatory environment. So we have Local Law 97 in New York City, which came into force in 2024, which puts a cap on the amount of emissions any building can emit, and you're fined if you emit emissions over a certain limit. The majority of buildings in 2024 are under that cap, but the cap gets lower over time. So in 2030, the majority of buildings currently don't meet that cap and will be fined. So there's also movement on how do we go about avoiding these fines and decarbonizing our buildings. So in general, it's a complex space. Buildings are important for addressing greenhouse gas emissions, and they're also where people live. So there's lots of interplay there. So how is building decarbonization implemented? So in terms of developing tools or trying to understand decision makers, we need to understand kind of the process in which it happens. So we'll have a building developer or a property owner, and they have a portfolio of buildings. We'll have, in this example, we have our Local Law 97 fines. So now there's a risk associated to each of these buildings of how much it's going to cost to do nothing. So they embark on developing a building decarbonization plan. But this plan is a conversation piece for lots of different stakeholders that have different metrics of interest. So lending organizations want to know what the return on investment is going to be. Or elected officials might be interested in green jobs that are generated from the project, or the number of affordable housing units that are going to be put in. Tenants might be concerned about their energy bills or rent increasing, and then federal funders, maybe not in this administration, might be concerned about the ultimate greenhouse gas emissions. So this plan is really a device to generate consensus amongst a bunch of different stakeholders that have different objectives that they're trying to achieve. So how do we develop a building decarbonization plan? Well, generally, it's based on building energy models, so physics-based models that are calibrated to some energy data of the building. You can do this for portfolio buildings. You can do this at the urban scale. This is an example at the urban scale. You create a set of retrofit options where someone says, you know, we're going to have the envelope suite of retrofit measures or upgrades we can do to the building, or this super duper high performance pathway, but these scenarios are developed and then they're implemented in these building models to see what the impacts would be on energy and emissions. The problem with this approach is it doesn't consider the people or the organizations associated with the building. So different organizations will have different business models that they're using to make decisions with. And then in terms of those questions around tenants and the impacts on energy bills, we don't have information to be able to do that type of analysis in our kind of standard approach. We only consider strict techno-economic objectives, and it's really time-consuming to generate. So I teach a class on building energy modeling and simulation, and that's what a lot of the students go out and do, is they go and they build these energy models to do these different types of scenarios in companies. But they have to physically, look at drawings, generate the geometry, so it's very time-consuming. So our approach is to try and incorporate some of this social information into our models, develop a generic retrofit library instead of looking at specific scenarios, pair that with optimization, which we heard a lot about yesterday, many objective optimization to try and understand the different objectives of these different stakeholders, and then be able to generate building decarbonization pathways. So our current work that we're looking at is how do these optimal building decarbonization pathways, how do they differ when considering energy burden and job creation? And our hypothesis is that when we actually consider them in our optimization problem, we're going to get different retrofit solutions. This is a departure because typically these additional co-benefits or burdens of energy burden and job creation are considered after the fact. You do your techno-economic analysis and then you evaluate these other things after the fact. But now we're putting them in our optimization so we can see what the difference in the solutions are. We put together our model. So we do typical modeling approaches where we have to construct our buildings in context. So we have geometry information about the footprints and the heights and the window to wall ratios. New York has a lot of data about this, which is a good context. There's construction materials that we have to assume around like masonry walls and the insulation and the glazing of the windows, and then the types of HVAC systems. And then here in this residential context, we distributed income based off of the local census data into each of these units. So we have our generic retrofit library. In this case, we took a small number of options for what we could do to the walls, to the roofs, to the windows, and to our HVAC systems, each with increasing efficiency and also increasing cost. And then for each option, we have the cost as well as the job hours that would be created from implementing this retrofit measure. So for this analysis, we did 3 different optimizations so we can compare the difference in the solutions. So we did a traditional techno-economic optimization where we tried to minimize cost and greenhouse gas emissions. And then we did 2 other additional optimizations where we minimized cost, emissions, and energy burden. And then the last one where we minimized cost and emissions and tried to maximize job creation. And we wanted to compare the approaches. So this is the results from like a standard techno-economic analysis. The kind of black line is our Pareto optimal curve. So we're looking at these two objectives of reducing emissions and reducing cost. The main thing is that the cost is increasing. And in this context, what that means is that these retrofits can't pay themselves back with a typical loan period. So this is why we need incentives to kind of make this make sense. We haven't incorporated the incentives in there, but they exist, but kind of it's expensive to do things in New York. And so that's why our curve goes that way. And similarly, we have the budgets. So interpretation of this curve is for any kind of budget that you have. This is the minimum amount of emissions that could be had for that budget. We can also look at what the retrofit measures are that are uptaken as you go from low budgets to high budgets. And the main order that we see here is that in this case, in this context, the first option, our first solution is to change the HVAC system to a mini split system, which is our least efficient, lowest cost electrification option. Then we upgrade the walls, which means reducing demand, and the roofs, and then the windows. So that's kind of the order of operations. We can go into more detail of the different levels of what that means. So here, it's the same Pareto curve, but we're just looking at the different options for walls, roofs, windows, and HVAC systems just broken out, so we can see what's being adopted at each different stage. But generally, at the lower budgets, where all the buildings are just getting mini split heat pumps, and the second kind of budget, those mini split heat pumps are paired with internal wall insulation. Then in our third section, we switch to ground source heat pumps, which are more efficient systems, and then also start adding triple glazing windows and roof insulation. And then in our last section, it's basically throwing everything in the kitchen sink. So we can kind of get at what these solutions are and what they look like. So we also do the our 3D optimization. So now instead of a Pareto curve, we have a Pareto surface. And the blue-green points are the solutions for reducing energy burden. And the yellow-orange points are the job creation. So we've projected this in this 2D space so we can see the difference in the solutions. And so kind of energy burden or job creation is into the wall, but the colors indicate the levels of that. And ultimately, what we see is with this type of analysis, when we incorporate these different objectives in there, we can also start to kind of have the conversation about the value of these different objectives. So like I kind of can't see it as well, but I've highlighted 3 different points, one on the techno-economic curve, a second on the energy burden, and third on job creation, all at the same level of emissions. And we can look at the difference in the solutions. I'll just go directly to that, of what the solution looks like. So this is just a representation of the solution. So we have 8 buildings, and we have retrofits to the wall, roof, window, and HVAC on the x-axis, and then the colors say the level of the efficiency of the solution. And generally for our techno-economic analysis, the focus is on HVAC electrification. But then as you go to energy burden, you start adding more passive measures with more efficient ground source heat pumps in the buildings that have more vulnerable units. So there's this question of which retrofit in which building. And when you start considering the distributions of incomes, not only do the solutions change of what you do in terms of trying to reduce demand and use more efficient systems, it's also in which buildings do you do it. And then for job creation, because it's kind of the inverse of cost, it's a broad space, but generally it's focusing on more passive measures and incorporating more wall insulation, because that's where walls and windows, that's where the biggest job creation is. So we can see that there are different solutions, retrofit solutions that you do if you're trying to achieve different objectives. And when we put it like this, we can kind of have that conversation where we can see the impact. Oh, well, we can reduce our number of burden units by 20 units, but it's going to cost us $500,000 to be able to do that. You can start to have those types of conversations. So additional work is to add additional metrics in terms of air quality and health, those organizational business practices. I've been talking to real estate professors to kind of understand the business models for that. And then also this analysis of this higher dimensional solution spaces. So we tried to do a 4D optimization and we just could not understand what was in there. But hoping that with like machine learning techniques, was talking about that last night at dinner, maybe with large language models, maybe you could kind of get some explainability of what these solutions look like. And then also I talked about how it takes a long time to do this type of analysis. We're hoping to start using computer vision to pick up some of this information about the buildings so that we can kind of automate that process as well. There's a lot of information you can already do in the built environment around that. And the techniques are just becoming easier and easier. So it's easy for us to pick up some of those techniques. The other side of the research that I do is around operation. So how can we operate our heating, cooling, and ventilation systems efficiently? How can they be comfortable? And how can they be grid responsive? So how buildings operate today is the only thing they're trying to do is maintain temperature. Like that's what they're actively responsive to maintaining temperature. Everything's logic-based controls, and all of the intelligence or trying to make the building efficient is embedded by the control engineer. And if something changes in the building, or even if you want to respond to a grid event, usually the operating engineer goes in and changes the program. So it's a very manual process. But where we want to go is we want to be able to kind of have this intelligence embedded by design, where the building is automatically changing its operation for different goals. So instead of just being responsive to maintaining temperature, we want it to be responsive to being energy efficient. And we also want it to be responsive with grid signals because there's going to be potentially this massive increase in electrification, and we can kind of shift when we heat and when we cool to kind of balance out some of those peaks. So kind of that's the future, what we want, how we want our buildings to operate. We're looking at using reinforcement learning to kind of answer this question. I've also looked at model predictive control, which is the other prevailing approach for this. The whole thing is a model. So how do you get a model of the building dynamics? A lot of times you need a lot of data to be able to do that. RL has the potential to get around this. So in general, with RL, became popular with playing video games, and you can just explore the environment. So the way reinforcement learning works is you take an action, you see how the environment responds, and then you do that over and over again to learn your system as you go along. And you can't do that in physical infrastructure because things will break. It's not a video game. So you have that agent has to be pre-trained in some way with some data. With operational data, it can take, you need a year. There's some approaches that have looking to shorten that to a couple of months. But buildings is a very conservative industry. People don't keep that amount of data for any reason. So in terms of scaling the solution, there's relying on existing operational data is difficult. So we can pre-train in a simulated environment. We can pre-train in a simulated environment, but again, we get back to this model question of how well does the model match the building. So this is kind of the area that we're focusing on, is training in a simulated environment and trying to transfer to a real-world environment. And the question is, how representative does this model need to be able to deploy in the real-world environment? A little bit more detail on that is that these kind of the same models that we can use for this building decarbonization study, we can also use them in this control context. But that model requires hundreds of parameters to be specified. And generally it's believed that, that's just too many parameters. We don't have that in practice. We can't use these models for this. Our question is, well, how well do these parameters actually need to be specified to generate good control performance? And so our hypothesis is that maybe they don't need to be so precise to lead to good control performance, because it's a different outcome that you're looking for. We have a test house on the Lamont campus, which is 45 minutes into New York State. And so we decided to use that to kind of test this hypothesis. So we decided to measure a key parameter of how the building's kind of physics. So the steady state heat loss coefficient, which is a measure of how much heat is lost through the walls, levels of insulation, as well as infiltration, so the amount of air that naturally comes in and out, if it's leaky, a leaky building or not. And then for the rest of the parameters of this model, we just used our general knowledge. We could do like the idea behind this is we could do an energy audit, go to the building, collect our general assumptions of what we think would be, and we just kind of fix those. So then we also created, so that would be like our baseline model, is those general parameters plus our measured steady state heat loss coefficient. But now we perturbed that heat loss coefficient by plus or minus 30%. And then created new simulation environments and trained agents in each of those environments. And then let's see how well those agents perform in the real world. This is specifically what we did. So we had one baseline model and 3 different mismatched models with different higher level heat loss coefficients, and we trained agents in each one of those environments. So our reinforcement learning agent, we just used DQ. We're trying to maintain temperature in the space, 20 degrees C during the day and 15 at night. We had electrical heaters, so we had a very simple HVAC system where we're just turning them on and off to maintain temperature in a heating season, and had states. Basically what we needed to know is what's the temperature inside and what's the temperature outside and what temperature are you trying to achieve. So we did this in simulation. So we took all of our agents and put them in our base case in our simulated environment to see what the performance was. Generally, they were all tracking within the plus or minus 1 degree C. That's the goal, is to stay within plus or minus 1 degree C of the set point. The bars outside of plus or minus 1 degree C is from the transition. So if you're maintaining 20 degrees and then the set point changes to 15, you have like a decay that happens and you can't actually track during that time. And that's what those bars are. But we do see kind of the difference in the, like if you see like kind of the difference in the wiggle of the mean set point is that difference in the heat loss coefficient that we saw. So we are seeing, if you train and you assume that there's less heat loss or more heat loss, you do see a difference, but it's a small difference. And so then we also did this and ported them into our test bed, into our test house, and saw similar results, but actually kind of better results in that we didn't see as much variation in the difference between the different agents. They all were between plus or minus 1 degree C, and the bigger tails are because the transitions were a lot longer than in our model, so our thermal mass was lighter in our simulation environment. But that allowed us to still have good control performance. So on the right is the temperatures that we were able to maintain in the building with each of the different agents, and they look the same because they're doing the same thing. So overall, we were able to kind of demonstrate that you could have this plus or minus 30% in what you assume this parameter is and still get good performance. So there's evidence to say that we don't need to identify these parameters so precisely. So this is a simplified case. So we're looking at trying to go to more complex tasks of temperature control, energy efficiency, and demand response, and more complex HVAC systems, heating, ventilation, air conditioning systems. And then we're also looking at model specification and trying to maybe not even use that complex model, but use some reduced order models to kind of use as a basis. Because the main idea here is that there's a lot of startup time to get these things running, and the reasons why these intelligent systems haven't scaled, they're not in every building, is because of how difficult they are to get up and running. So if we can go to a building, collect a few bits of information, generate a simulated environment, and have an agent ready the next day, that's a really big improvement on this scaling ability. So that's what we're doing now, so thank you. And looking for questions.
Thank you very much.
Yeah.
Interesting, impressive presentation. So there is a question.
Thank you for your very nice work. Have you seen any differences between the traditional houses and more modern houses, in the sense that, for example, we've seen that in Greece most traditional houses, they have thick walls and small openings, whereas modern buildings tend to have a lot of glass surfaces, which means it's more difficult to heat and cool down. Did you see such a difference in the houses in New York, or something? You see different behavior for the more.
Yeah, I mean that's fundamental. Like you're going to have different characteristics, and if you talk to someone who does building energy efficiency, you'd be like, don't do those windows. Like, well, the model is already looking at trying to identify those properties. So if we know that there's a full wall of windows, we can incorporate that into the model. So it's just different dynamics. So there'll be a difference in the thermal mass, the impacts of the solar gains, and so those are the things that you need to model. And that case of the solar gains would be more difficult. It's more challenging because it's very context dependent. I mean, generally there's latitude and all of that stuff, but in terms of what's around it and and shading and what actually gets into the building, so that would make it more difficult. It'd be but fundamentally, those are the types of things that our models know how to analyze already. Urban heat island effect, yeah.
But they changed the road pavement to have 1 or 2 degrees lower the temperature in the city. So does New York City, for example, try to do things like that, change the number of plant more trees, change the pavement?
Yeah.
That will affect a lot of the buildings because let's try to control the temperature when we can lower it a little bit from the outside.
Yeah. I know kind of work on urban heat island effect is an area in of itself, and not one that I focus in, but there have been trying to add more trees and things to the environment to reduce temperatures, green roofs. Haven't gotten to painting, using these ultra white coatings. Yeah, I don't know actually what they're doing to address the urban heat island effect. I don't know if anyone knows. Trees? Just trees? Okay.
Thank you very much.
Thank you for your insight and presentation. It's very interesting. I want to ask about the connection speed system that's for the works in city. It was very difficult to play out with the greenhouse and business and stuff as well. So do you believe that if these methods were actually indicated to most buildings in New York, that situation with the steam would be better? Because I know for now, for people working in streets in New York City, it's very difficult for them to breathe, especially during the summer with those emissions. Could decarbonization actually be something that would solve
impact that? It's kind of like a two-part question, like of the steam system and whether or not it's viable in the future, and then also what would be the additional benefits of not having the steam in terms of the district steam network. Is that your question? Yeah, okay. So the steam network, it's an open question, and there are people coming off of the steam network. And so it will collapse because the less people that are on the system, the more expensive the steam is, and it'll get this cascade failure. So there's a question of if we want to keep it or not. In general, from a mechanical point of view, you wouldn't transport heat at that temperature for this purpose. So it's inefficient in its design today. But there are questions about changing the fuel source so you can keep the system. There are space benefits to having a network steam system because you can just have a heat exchanger in your building instead of your own generation system. But it's an open, it's a open question, and it's also kind of a politics question of whether or not we want to keep the system versus changing to something else. And then the benefits to not having all of that heat underground, I think yes, in terms of urban heat island effect, it would have big impacts. But generally, like having such high temperature process steam going around is not what we would want to do thermodynamically. Yeah.
Can you just think about how these results depend on building size? So, you know, like I live in a 6-story co-op built in 1898. I'm sure it's super inefficient. There's a huge boiler in the basement, but it's not that many people in it. And like, so how do the results depend on it, and also how much of the city's emissions come from buildings? In other words, if you were to do a global solution for the city, you know, how does that come into it?
So we want to do a global solution for the city in this way. It's a computational challenge, so we're looking at doing some surrogate-based optimizations to do that. But it does depend on size. In terms of what solutions, your surface to volume ratio, the size of your windows, all of that will change what the existing efficiencies. In practice, a lot of the change happens at the end of life. So if you already have an old boiler, then maybe you'll do some changes. But yeah, it does depend. We've done lots of sensitivity analysis on this particular case study to see how the answers change. And like right now, windows aren't really prominent in these solutions. But if you increase the window to wall ratio by like 20%, then windows come in as a big factor. So it's really dependent on, it is dependent on your particular building kind of configuration, the courtyards affecting, you know, so I think that's why it's important to have context specific, and that's why building and practical building analysis happens at the building scale. If you're trying to figure out what to do, there's the saying every building is a snowflake, is these sayings in the fields, and so you have to address it. Other people don't feel like every building is a snowflake. It's a thing about like what's the foundational model you can use for that. But yeah, all of these things do play have an effect on what the solution should be for your building.
I have the sense that some of the regulations are focused on the larger ones, but is that just because?
So,
I mean, it's easier to regulate if there's so many.
Yeah, bigger bang for your buck. So buildings over, what is it, 25,000 or 50,000 square feet? Can't remember which law it affects, but yeah. So they're focusing on the building from a policy standpoint. It has a big impact on emissions, and also those are usually institutionally run buildings. So you have an owner that has a facility, you know, they have a operation behind them that can actually implement those changes. So practically, it's a good starting point.
Thank you for an excellent presentation. I mean, this is new material for me. This curve shows the reduction in CO2 emissions as a function of cost. It's very clear, the larger the reduction, the higher the cost to achieve this. So we go to a building, multi-story residential building. What is the incentive for the owners of the building or the individuals, if they own their apartments, to pay a significant amount of money in order to achieve this reduction? How long is it going to take for them to recoup their investment through, let's say, lower energy bills?
Yeah.
But even if this is the case, let's say you recoup after 5 years or 10 years, if we're talking about low-income families, they might not even have this amount of money in the beginning to pay to make this update.
Yeah.
Is there a way to get around this?
Yeah, so the paybacks are really long, and that's why building decarbonization is not happening in mass, right? There's particular contexts in which it can work and different financing mechanisms. So this is about the financing mechanisms that you can have. So there's incentives that you can do, but there's also things to like energy service providers. Well, they will take on the capital costs, implement the solutions for you, and then you pay them back through, you keep paying the same energy bills you were paying before, but your energy bills are actually lower, and so they get to recoup their money that way. And then in terms of low income, you would need to fully subsidize that. But on top of that, it's a fragmented industry. So like even trying to figure out what to do, or if anyone's tried to do anything with their home, and you have to find your own plumber, and how do you know that this is a good person? Like there's a lot of process that could be streamlined to help that as well. But yeah, that's why I want to incorporate these organizational questions, these individuals, because their ability to act is dependent on these kind of social and organizational contexts and governance contexts. Yeah.
Thank you very much for very interesting
All right.
presentation. So the next speaker is Professor Zografou.
All right, thank you.
Kalimera, good morning. Thank you for the kind invitation. I'm going to be very fast because although I have about 55 slides, just we are behind the schedule. So my name is Anastasios Doulamis. Where is the presentation? Sorry, the presentation? Yes. Okay. And I'm professor at the National Technical University of Athens, and I'm going to say something about robust, trustworthy, explainable, and robust AI to climate change effects, some works that we have done in our lab. Let's move here. Okay. There is an important issue about environmental impact due to urbanization, and this about the city consumes about 17% of the total world resources, and this means a lot of challenges in economy, in health, in social activities, and there is a lot of important issues in pollutants, air, noise, water, etc. This has causes also some non-communicable diseases. We have just gained a new project in the European Union, which is called Athens. Now we are in negotiations about this, the effect on the environment and the pollutant with AI in non-communicable diseases. Just is some few strategies of the European Union about the Green Deal. The Fit for 55 strategy means the guidelines to reduce the gas emission, the water protection, etc. But all this, there is a challenge in urban area where the multiple pollutions and the combination of these maybe have exceeds the related risk, and there is some challenges in this way. Another important issue that we need to speak about is the social aspect, because all these policies that we apply usually are not for all. There is vulnerable people, elderly, children, immigrants, refugees, minorities, people which live under poverty of low income, and of course the environment and the impact of the health and the environment of the climate change on them and on the infrastructures are different. So we need to take care of these actions as well. There is some technical limitation, the high cost, and the sensorial data that we need to take a lot of data from different types of sensors and to integrate them and to fuse them from different modalities, from interoperability issues and etc. The integration lack, the limited comparative model, the lack of guidelines, etc. Now there is some solutions that we try to find out in this work that is the DF project that is going to be starting probably in the autumn. It tries to harmonize the data to leverage cutting-edge technologies and to have new tools, sensor data, AI tools, novel solutions in order to apply all these models. This is the pipeline of the whole work. So the innovation here is that we try to create some living labs for creative labs of humans. That is very important for different types of users, policy makers, stakeholders, simple users, vulnerable people, that we try to testify under in prospective studies. Not prospective, it's not a medical study, but this is the kind, using also psychological and organization models. We try to find a nudging platform for smart mobile applications, pollutant monitoring, using different types of pollutant monitoring applications for soil, water, noise also, which the noise is also one pollutant, and to have some epidemiological model and Internet of Things in order to apply all these items. Now some works that we have done in our laboratory, we have done some works using retrainable neural networks, which means it's actually was an old work in my PhD thesis that now we call it at that time retrainable neural networks. Now some works is continual learning. That the idea is to update the weights, the parameters of a model, of a neural network nonlinear model to fit the current condition, because you cannot find one model that fits to all conditions. It's some kind, a kind of overfitting. It's not overfitting, of course, but it's an adaptation mechanism. We have applied some tensor-based learning models, which is a new learning model that fit better than convolutional neural networks, especially for geospatial data, which is very important for the climate change. And in this we have a rank 1 and rank K, rank R decompositions of the model using some tension theory. We have used some adaptable neural networks model, especially for deep applications, in order to be suitable for different types of conditions. We have applied some vision transformers, especially for environmental monitoring, for forest deforestation, detection of the emissions. The challenge here is that the data, the classes are imbalanced. So we have very small classes, so we need to have some techniques in order to compensate in these examples. A lot of works of trustworthy and explainable AI, which the current work, this is very important in order to say to the models why the output is this. We need to interpret the output to give some explanation of this. We have applied some explanation and for COVID-19 pandemic and how this spread throughout Europe and how the environment can be affecting this, and we find some very interesting results. For instance, that the green cities have lower impact in the pandemic spread like the dense cities. This is find for the statistical analysis. We don't know if there is complying with biological or other mechanism, and of course, and some other issues using the geospatial analysis and the event of the data. Now, I'm going to say some applications that we have applied. We have applied some, for instance, in the HART European Union project that is going to end at the end of August this year, and I am the coordinator of the project. We have applied some mobile apps for heart monitoring and the clinical study in order to find out how the environment affects the health, and in 4 dimensions, the psychological and psychiatric health, the mental actually health, the cardiovascular activities, the respiratory problems, and the metabolic, which actually the diet and the metabolic disease. And we have developed some tools for this, which this one watch, which from this project with record all my heart, the split rates, and set it to a system. And when I am visiting some green places or not places, and we use some statistical analysis to find out some results. This is a clinical study with the Medical School of Athens and 3 other medical schools in Europe. So it's not just a research, it's a clinical study also. We have applied some research of environmental impact on communicable diseases, what say for COVID-19, and this is a very important issue. What we have found that the green places have some greater impact on lower impact, so it's more important to live in a green place in order to decrease the communicable diseases. One other project that is also ends at the end of August is EU police. It's from the Greek word EU, means good, F like euphoria, etc. And the polis, which the Greek word means, as you know, city. It's in here we have 4 cities in Europe: Lutz, Piraeus, Belgrade, and airport in Durban, and we apply some natural-based solutions, green solutions, and we apply some statistical tests and AI tests in order to find out how these solutions can affect the well-being and the health of the citizen. It's not a clinical study now, it's just a statistical survey. Instead, apart from the heart, and we have applied some games also, tools in order to find out how the trees and the scenery and the other landscape and the motivation and the urban planning, how they can affect all this information. Now some works on for another European project, Expedite, which Latvia is the coordinator, and where actually the technical manager is to apply energy efficiency buildings and digital twins in order to design the energy of some largest part of buildings like technical campus towards, for instance, Catastrophe 4.0. And this is some example of the motivation that to try to find energy efficient cities and increasing the energy feasibility and the catastrophe office, the CAPS. And we have some challenges, for instance, the fragmented data and how we need to visualize them, the limited real-time performance and the integration and the poor integration. And we try to integrate all of this in geospatial data. This is the architecture of the digital twin in this work, and the paper that is now under preparation to be submitted. And for the architecture, some example, for instance, we have the 3D model, and this is the campus in Latvia. We have then the 3D model using photogrammetry and computer vision tools to train the model, to train the sensors, and we try to visualize the BIM, the building information modeling that we apply in this information. We try now to find the solutions, and we realize the visual examples and how the energy is affected towards energy efficient buildings. We have done some work using 4D modeling, meaning 3D geometry plus time. It is for some cities of Calv in Germany, and this is the city of Asinus Church in Cyprus, and how the model is motivated from time to time from the 19th century to 21st century. Some works using inspection of monuments. For instance, we have some cultural heritage monuments and stones, and we try to quantify the material degradation using computer vision tools, not a chemical like the chemical engineer Professor Lepropoulos does, using, for instance, chemical analysis, but it's of course non-destructive techniques in the analysis. Some recent works are using land classification from satellites or drone images. We try to classify the lands from, especially from agricultural analysis, and this is some results. This is an interesting paper in a major conference of hikers that have received more than 1,000 citations, although it's a conference actually paper. We try to find out now, we have a European Space Agency for project that we classify all Greece inland using 22 classes. Some of them are very small and tiny, like tiny roads and agricultural roads. And a very difficult task. We have actual measurements of more than precision, and we call more than 50%. And we find out this is some results. The training, the tiles in Greece that we have taken from training from different types of periods, because this is a project that the ESA, the European Space Agency, wants for search and rescue from climate change monitoring, to have each year the map of Greece. And we have used a UNET training model for the classification with 7 bands and different modalities, including the bands, some indices, the DEM model, which is a feature that is very promoted by the ESA. And we have some results that give the accuracy more than 50%. And it is a result for different classes. You can see inland, water body, burnt areas, dense urban areas, sparse or peri-urban areas, bare rocks, agriculture, trees. And this is difficult because we have also different weather conditions, clouds that we need to remove the clouds, snows in the winter. And this is some results of the majority voting, some classification results of different classes of the Greece, and we try to validate it using also external sources, because from ESA the validation and the different is a key issue. And this is some example of the map of Greece in this land monitoring. We have applied some explainable tools for land monitoring using sub values, decomposition of deep lift, and these some results also from these explainable resources and the analysis. One recent work is also the HERON project, which have ended end of May, that also we are the coordinator of the whole project. It's a project for computer vision and artificial intelligence works for monitoring of and maintenance of roads, not only monitoring but also maintenance using robotic system from Spain. This is the whole backbone of the project, with the maintenance also inspection is very important. Some results from crack analysis, detection of cracks and holes, which I believe needs a very difficult task, more difficult than other computer vision techniques. We have also done it in tunnels, in another research project which have ended before 3 years of perspective. We have done it with a robotic arm of 7 meters length to find out the cracks. And we're very happy when the robot finds a crack with the width is 1 millimeter. So it's very important in this issue. Some results from the road, from detection of holes, cracks, and other anomalies in the road. This is also some results from the cone detection in order to improve the safety and the maintenance. And if we detect the cones, then we have applied the robots from Spain, from one company, and they perform the maintenance. Ευχαριστώ πολύ. Thank you. I was quickly fast, of course, but I try to be the best.
Any danger in relying mostly on digital twins of structures or buildings or cities instead of actually looking at actual structures? I mean, I see a balance there. You can either focus on putting sensors on actual buildings or working with their digital twins. What's your opinion? I can see the trend, but
you know, it's a good philosophical question. In every decision, there is a trade-off. I cannot say that I think so that it's better for the application that you have and what you need to do. Of course, it's easy function, digital twin, and easy function also in papers, in projects, etc. But this doesn't mean that the effort you need to construct a digital twin is so simple. And I think so that it's better for complex situations like mechanical engineering, plane design, chemical probably structure design, rather than for simple things that you can do it using a simple platform of mobile, either static mobile IT platform.
Thank you again, Tassos. The next presentation is
Πολύ γρήγορος. Τι να κάνω. Όσο ρωτάω. I'm sorry.
Invitation. My name is Andrew Smith. I'm a professor of civil engineering and engineering mechanics at Columbia University, so a colleague of George's, and I have very good associations with NTUA, as I've had some outstanding students come and work with me over the years. So today I'm going to talk a little bit about some work that we're doing at Columbia in the general area of smart cities. Because I think the objective here was to look for and explore areas where we could collaborate and engage. I probably have more slides than I would normally like to, so maybe some things will be somewhat superficial. Here we go. So a little bit about my research background and how I got into smart cities, because I think that's sort of important to understand. I came at this from the field of infrastructure monitoring and assessment, and in civil structures is often called structural health monitoring. So basically it's the area of cyber-physical fusion. We talked about IoT and its ubiquity. Obviously you start networking that. We couple that with our ability to model things very well, tremendous computational power, and one can start to really understand our civil infrastructure, manage it, and potentially control it as well. So this is just one small project. This is from a number of years ago, working on the Manhattan Bridge, and I've worked on lots of different infrastructure in New York City. Obviously the key issue here is that our environmental loadings change over time, stress our aging infrastructure. In this case, this is a steel bridge, and so this is a stop motion video, and you can see all of the components in the bridge would be subject to tremendous fatigue over its life. And so we were asked to model this bridge for a rehabilitation project. And so the way we do this is we instrument with a variety of inertial sensing, and in this case it was an early use of differential dynamic GPS as well, where we could really accurately model the deformation deflection of this kind of structure. And so it gives you insight into how it behaves. And these are some of our students that are up there installing the sensing. So these are fun projects as well. But basically this, I would say, the field of structural health monitoring is kind of the early incarnation of what now is fashionably called digital twinning. And so we have some kind of exposure, environmental exposure. We have our system. And now we are looking to build some kind of physics-based or data-based twin, if you will. And we can use that as we train it to come up with an accurate model. We can use that to be able to make decisions, basically. So we have an assessment, we can assess for damage, provide remaining life prognosis if you have some material characteristics, assess the effectiveness of repairs and modification. That was the purpose of that study. And the performance under extreme event scenarios. So just a little, I mostly work in the sort of more physics-based learning. So the kind of, the problem here is that you might have a very complicated system made up of tens of thousands of components. And so it's a challenging learning problem. In this case, we worked manually first. We shrunk the parameter space. And then we used some learning approaches in order to shrink the parameter space further to tune our model. And just to give you some idea of the results, we were able to then tune this to accurately identify the mode shapes and frequencies for this system. So these are normally very, very challenging model updating problems. More recently, and this is just a sample of some preliminary work just using more neural networks, but coupling this with, again, a physics-informed constraint that you apply to our neural networks. In this case, we were doing something maybe even more challenging where you're also trying to estimate the input force. So it's very difficult to measure often the wind loading, for example, on a structural system. So just in reality, that's a challenging problem. And so we were doing some preliminary work on this where we're estimating the input, the time invariant parameters of the system, as well as unmeasured states. So areas where we're not measuring the response motion. And of course, that's generally sort of an ill-posed problem. And so the trick, if you will, is to have to impose some kind of prescribed, in this case, spectral information or some other information about the input force. This is just, again, preliminary work, but just showing you, we've done this for nonlinear systems, but I didn't want to give a whole lecture on this. And so just to show you some idea of the kind of performance here on the right. Whoops. Oh, this is the kind of fit we get for the force estimation, for example. So, again, my main background is in structural dynamics and that side, but my interest in sensing and monitoring started to drift over the years, and this is an example actually very much like in the last presentation, early work in road surface monitoring and characterization. And so this was work actually done with Philips North America research, where we basically created a device, IoT type device, attached it to a vehicle, and we're able to then geotag different kinds of road imperfections, and then came up with an AI-enabled data classifier. We drove this around in 5 vehicles from our team, and we're able to characterize various road imperfections in different areas, and our data was, or the response by New York State corroborated our findings, which highlighted areas where we had poor road surface conditions. So this kind of idea, as you see, has now been picked up by a lot of others in a variety of ways, and it's just an example of mobile sensing effectively for your city and the characterization of your city. So if you take this idea of mobile sensing, that brought me into a different application, which is for understanding road safety. And so this was a project that I did with the New York City Department of Transportation. And in New York City, all of the vehicles that the city owns are instrumented with a telematics device, not to do what we wanted to do, but to understand like when to change the oil, and maintenance schedules, things like that for the devices themselves. So it's an asset management a need. So, however, those telematics devices are getting all of the information from the vehicle engine. And in this case, we were looking at speed, hard braking, hard accelerations, and obviously everything is geotagged. So there were, we took 4,000 vehicles. There's a larger set of vehicles, but we took all of the vehicles that were like cars, cars or like cars, and we would track them over the course of many months and years, and would understand then how the drivers behaved as a function of the road network and the road design. So we were interested to find out, does the way the road is designed impact how dangerous it is from the driver's behavior in an aggregated sense, not the individual driver, but in an aggregated sense. Yeah, there's some small interesting stories about how to denoise in GPS challenged environments. But this is the kind of data that we were able to come up with. So every single road, lane, very accurately we were able to come up with speed profiles and other information about how drivers behaved. But just on the right is another interesting example of the kind of thing that one could do from a point of view of emissions tracking. This is tracking idling, which is when the vehicle is not moving, but the engine is on. So giving you an idea of where people are unnecessarily emitting, usually waiting for parking, that kind of thing in New York City area. Anyway, we were able to come up with all sorts of different parameters, again, very accurately by every single road segment and direction. For example, where people were hard braking, and then we could start to correlate that with historic injury collision data sets as well. A number of other different metrics that we could track, like where people turn left. So where one turns left is associated with collisions as well. So all sorts of, again, road network information, but that all information that are where the variable is really how one behaves on the network. These are things that one can start to glean, and effectively then we built a crash prediction model. And this is used in New York City to help redesign and to inform their design, and also to do before and after analyses. So if you put in a speed bump, or if you change the light timing, this kind of thing is now used. But just another, and these are a couple examples from two different companies that we've worked with. This idea of mobile sensing is really quite powerful because your sensor is traveling all over the city. You might not have continuous sampling at a given location, but you do have very frequent updates. And so this is a dash cam company, Nexar, which is giving us photographic information of conditions on the road. And Geotab is another company that does fleet telematics. And if you have access to everything that's coming in on a vehicle's computer, you also have outdoor air temperature. And so you have mobile sensing basically, which is giving you in real time the temperature on the street all over the city. And so one can study these urban heat island effects. And some of these things are really highly localized. So just an idea. That took me to another area, which is I'm still working on, which is in optimization of emergency response. So this is a project with the fire department, where in New York City, this is a map of the 5 boroughs. We have about 60 hospitals. And New York City was noticing that its response times for ambulances was increasing, so slowing down over time. And so they wanted to see if they could come up with some data-driven solution. So we took 5 years of ambulance travel data, so there are about 1.2 million trips per year to hospital, and we improved basically their suggestion of which hospital you should go to. There's 2 parts of the problem: which ambulance comes to you, and then which hospital that you go to. So I'm just showing you half of the problem. It's the easier one to describe quickly. And this has interesting sort of statistical challenges as well, because the data itself is based on the past, and so generally one is going to a nearer hospital, so you have far more samples from certain trips than you would from others, from some location to given hospitals. So we have this difference in sample rate. So obviously travel time has a tremendous amount of uncertainty. There's variability in the travel time, and as I mentioned, there's variability in this sample count versus route. But to boil it all down, with some hybrid modeling, both the data-based, and then for long trips, we also had to include a kind of a physics-based model in order to estimate those. We were able to come up with maps like this, which basically give you sort of catchment areas for each hospital. given the time of day. And then also the probabilities associated with the fact that you've chosen the best order of ranking of the hospital that you should select. And over New York City, this saved, for all of the changes that we made, this saved over a minute in travel time to hospital. Again, this is only half the problem. And this also is deployed at scale. So this is how New York City's two-hospital selection pattern works today. So again, these are the kinds of things where if you monitor, you collect information, you can start to impact urban life, quality of performance of the city. And so this kind of gets me to what I really wanted to get to, which is kind of looking sort of broadly into the future. And I know this workshop is about sustainability and climate. So, and much of what I'm doing does not explicitly directly get to that, but I would say that cities are greener. And so we need cities to work. So, and we need people to want to live in cities. Just the density, physical proximity, the building stock. I know we can improve the building stock, I'm not saying any of that, but cities inherently are better from the point of view of sustainability. And so this is, again, an American perspective, but this is the kind of per capita greenhouse emissions, and many people have done these kinds of studies, and you see that with the exception, I think, Houston, generally speaking, and there's reasons for that too, but generally speaking, cities perform much better from a per capita emissions point of view. But cities have a whole host of challenges in terms of livability, I would say. I've talked about aging infrastructure, there's technological disruption, e-commerce, the congestion around the chaos basically on the street, coupled with micromobility, so different modes of transportation mixed together. We have aging population, always stretched municipal budgets. We still are having transitions from rebounding from COVID, certainly in the United States, and general social and economic exclusion challenges as well. So all of these challenges and trying to address these led to an engineering research center that we have established and was awarded in 2022. This is the Center for Smart Streetscapes. So our mission is to forge livable and safe communities through hyperlocal streetscape applications. So we're looking at newer kinds of smart cities applications that are sort of at the human scale as opposed to solely at the city scale, where I think a lot of work has been done. So the application domains that we're focusing on are road safety and traffic efficiency, public safety, assistive technologies, outdoor work, and then also hyperlocal environmental sensing. And this is sort of our research framework and objectives. I know there's a lot of information here, but our objective is really to develop a sensing, communications, and computing platform that can support all of these different kinds of next generation technologies concurrently. And importantly, and we work a lot with our stakeholders, so we feel that these things should be done in a community accepted manner. So in a lot of parts of the world, Europe, US, some smart cities technologies have been rejected really out of privacy concerns predominantly, and it's sort of the surveillance notion. And we feel there are ways to handle that. So there can be benefits without necessarily the cost. And so you can see in our research framework that security, privacy, and governance is very important. So we also have sort of core technologies in the communications computing. So this wireless edge cloud layer. Situational awareness is taking urban sensing and then understanding the context in real time. And then we also work with social scientists as well to define this community acceptance of the trade-off between functionality versus potentially privacy costs in our technology. Sort of the catalytic technologies that kind of launched this initiative are high bandwidth, low latency communications in urban environments. Basically the ability to be able to communicate a lot of data, and also the edge computing. So being able to push computation from the cloud closer to the streetscape layer and that allows one to do things without a lot of delay or latency. So you may have less computational power, but perhaps you don't necessarily need it. You can still coordinate things from the cloud, but this edge architecture and proximity can be very beneficial, and also very beneficial from a privacy point of view. As I mentioned, we engage with community. That's important in our entire process. But we also, as part of our center, engage with industry, and so innovation is a key part of what we do as well, and also train our students in terms of sort of the entrepreneurial skills that they might need if they wanted to launch a company or a startup of their own. So that's part of our center's process. We have 3 real-world test beds with our partners. So the one in New York City is focused primarily on advanced urban wireless, so it's a beyond 5G network. And this is in West Harlem, basically just around the Columbia main campus, on Morningside campus. Another in West Palm Beach, which is focused on pedestrian and cyclist mobility. And in New Brunswick, New Jersey, one that is basically a V2X, so a connected vehicles test bed. This is probably too much information, but just to give you an idea, we're building a sort of a software stack that can then enable all of these different kinds of applications to run concurrently. I don't know how well this comes out, but there's a few sort of core features that we need, sort of multimodal data synchronizations. If you're bringing in data from different kinds of sensing, one needs to be able to synchronize these are sort of core features. Then spatial temporal fusion, from the spatially, how to understand and be self-aware of where things are. Positionally is also important, and the data distillation. There's another layer which is getting integrated. So this is sort of the current state, but we're also integrating a privacy architecture into this, and this is being ported over from like brand new W3C web standards, which one of our faculty members is developing, to bringing those in for different kinds of access, either local, from the extreme of local and immediate user kinds of needs versus aggregated data across different sensors. There's different ways that we manage the privacy for that and control, and are able to audit that as well. So just an idea of how we think about privacy in computer vision, for example. This is an example from just next to campus. So here you're seeing a raw feed of our data. You can see some people, maybe, I don't know if you can see them working in the road here. So here in the edge, at the device, at the camera, we're able to strip out the identifiable information. And so what you're seeing then is simply, effectively, the metadata, the position, the classification, and then we can share that kind of metadata, which is anonymized, with any application or third-party app. And that might suffice for the use case and application. This is just, so I'm just going to show you a few examples very quickly. These are not exhaustive. This is from one of my colleagues in civil engineering, transportation-focused example, where she's building up digital twins so running in real time of the transportation flow. And again, this is all driven from, in this case, camera feeds. It's that same intersection, the same extraction of anonymized data, but then building, let me see, I don't want to rush this animation too much. Whoops, sorry. So then it is able to, okay, now I don't want to go back, but this is running in real time, then a simulation, and then can also be used for simulation that would be used for autonomous vehicles, like Carla, that kind of thing. Here, some research examples. You could run federated traffic signal control. If you can smooth out the traffic signal, obviously there are efficiencies to be gained from emissions point of view and general flow, depending upon what your objectives are. And so, again, it's just one other example. This is an example where we're helping a blind user be able to wayfind. So again, the infrastructure is sensing the scene, The user has an app, has a destination, maybe they want to walk to that bus stop, and it can give them turn-by-turn instructions, very precise, inform them if they're veering off course, alert them to traffic, cyclists, whatever. So that's a kind of real-time interactive application, which I think otherwise would not be possible. This is an application where this is in terms of hyperlocal environmental sensing. We're inferring the wind speeds basically from drone flights and the IMU information from drones, and this is important from the point of view of deliveries, inspections. There's all sorts of potential urban drone applications. This is an application of using, again, traffic cameras to, and this is at city scale actually, to understand traffic flow. So you've already deployed all of your traffic cameras, you might as well get some information that's useful and actionable. And so this is actually some analysis that we did after there was a congestion pricing change in regulation in New York City. And so we were interested to see if we could detect the secondary effects across the city and the changes of mobility patterns. Another example here, and this is important if we want to do collision avoidance alerting, where we need to come up with a prediction of trajectories of different kind of vehicles, pedestrians, what have you. And just a last example here where we're also using computer vision here to characterize different kinds of micromobility. So scooters, motorcycles, bicycles, e-bikes, delivery. So we're, in some of these examples, they go by quickly, but you can see we're actually classifying, detecting the box that's on a delivery cyclist. And the reason this is important in New York City, A, they're thinking of regulating it, but B, you can also see that the number of collisions, injury collisions, is increasing as we get this greater mixture of different kinds of micromobility into our vehicle base. And micromobility, I think in general, is a good thing, but it's just how we handle it and manage it, but to be able to count it is a challenge in and of itself. So I'm showing you only really a small glimpse of the projects that are going on within the center, but fundamentally our objectives are to improve quality of life, work to create businesses, develop processes that can be replicated other places, not just in New York. Importantly, come up with these standards for privacy and security, and then the governments will actually adopt those policies. So with that, I'm just on time, and I wanted to thank all the people that are involved, and I'm probably forgetting someone here, but happy to take questions.
Information from GPS or other sensors. Are there any platforms where citizens, the kind of VGI, volunteer information to feed your system for phenomena or incidents that happen all around the area you monitor? Is it something that you think?
Yeah, so that's a good question. So we don't yet have platforms for sort of citizen sensing. I think that's is that what you're asking about? Yeah, so one of the applications I skipped is one that's more of an augmented reality application. So for the kinds of technologies I'm talking about would work well for augmented reality because you need very accurate positioning and responsiveness. But one of those is around like cultural heritage, particularly in Harlem. That's an area that one of our test beds is in. So we want to be able to give people the history of something or show them what the street used to look like. So you could, but part of that application is also that users can start contributing their information as well. That's the one application I can think of where we are thinking already of contributing. But I would say that many of the things we're talking about are passive. So the users don't need don't need to have a device, they don't need to contribute, but hopefully will still benefit. So the exception would have been the blind pedestrian, for example, or vision impaired, or low vision pedestrian. That person needs a device. But if you think about it, everybody else in the scene doesn't have a device. They are being detected, but we don't need to know who they are, and that's anonymized. So generally speaking, we don't have in our thought process, I wouldn't say it's a high priority to have contribution of data, but there could be applications where that becomes important. The reason I'm hesitant to go far in that direction, you could have a very sort of biased kind of data sets, but perhaps there are some good use cases. But I'm happy to talk about further.
Do you have any other questions? Yes.
I'd like to ask about the problem that you described for the fire department observing the hospitals who have considered a similar problem in case of a catastrophic event. We had to minimize the inspection time of the structures and the infrastructures. So in that case, we formulated a problem composed by a districting problem, assigning to inspection crews to different districts, and then a routing problem to guide them how to operate. How did you formulate the problem you described?
Okay, I don't know how much time we have, but yeah, so we have a very good travel time model. That's the first thing, and that's data driven. But also it's a routing based model. Remember I said there's a sort of a hybrid aspect to so we bring those two things together. So we have effectively like a physics based thing, but calibrated by data, because the way that an ambulance moves is not the same way that a vehicle moves. So you can't use conventional traffic data. So that's the first part. So then again, in this two hospital, we sort them by how the arrival time. So we have but the other problem, which I think is probably more like the one you're talking about, is the unit, the ambulance to incident. Okay, so that one, we have a set of resources. In New York City, at any given time, there's about 400 ambulances that move around, and the current rules are that they do their job, they go to the hospital, then they go back to kind of a base station. It could be an intersection, so it's not necessarily a building, and then they wait for the next call, the next deployment. We are working on something where we think, and we've shown early, one of my recent students, that we can have a dynamic reconfiguration. So instead of always waiting there and then always having the nearest unit go, sometimes it's better to have a different unit go and kind of continuously adjust the map effectively. That's the closest thing, I think, to what you're describing that we're working on now. So I'm working also with colleagues, yes, they are listed here, who are in optimization and the operations research for that kind of dynamic repositioning piece. So there is an optimization, there's a routing problem, but this travel time modeling is the part that was not well understood. Yeah.
Thank you very much.
Sure.
Civil engineer, transport engineer. We belong to the traffic engineering laboratory, and especially my team is one-third of this laboratory, mostly working on AI applications in various topics of traffic engineering, namely traffic management, traffic safety, ITS and automation applications in mobility of various types. I really enjoyed the presentation of both Bianca and Andrew, which was quite technical, and I would like to stand at the interface of between science and real-world application, because it's extremely useful to see ourselves out of the problem that we solve and try to understand how actionable is all the things that we presented so far and all the research that we conduct in our laboratories. I will try to show that we really have a true impact in formulating policies. I will show how European Commission formulate policies in relation to mobility based on our scientific outcomes. Although when I say our, I mean the consortia that are working on this very fancy European project. Then I will explain why it is important to follow policies, because top-down policies may disrupt our science or the manner we conduct science. And given some challenges that I think that exist in every city and every nation worldwide, I will explain why we need to have a different mindset when it comes to AI. And the mindset that we promote as a team is thinking beyond accuracy. So I will focus on large-scale implementations and urban road networks. I will try to explain all the thinking behind my team and how we approach problems on network and traffic operations. This area, this field, let's say, it requires complex and multi-level decision-making, strategic, tactical, operational. For example, I want to know what type of taxation I need to induce in a city or a region in order to reduce car dependency. Or I am in an area, I have a concert and a ball game, a football game at the same time inside a specific area of the city. So tactically, I need to know next day what type of traffic management plans to implement tactical level. And then I have the operational part, which is quite tricky, and that says that, okay, I have a flood in Kifisos Avenue. I need to know right now what type of measures I need to implement so as to mitigate the effects of this disruptive event. And I know from 40 years of research that there are some aspects in my problem. Why this is so complex? Because we have multimodality, various types of modes acting together in the same network. We have the layer of technology, automation, and connectivity that Andrew explained before. We have this multi-layer stakeholder environment because all the things that we have around us are services that are actually operated by authorities or companies or somebody else. So there's always some human involved in this process. And then we have all these externalities coming from weather, large-scale events like COVID-related phenomena, disruption, system disruptions, and of course all the cascade effect that comes when, for example, we have interrelated networks. For example, I have power supply failures. What will happen with the metro and how this disruption in the metro system will affect delays on road traffic. So everything is interrelated, and this increases the complexity of the decision-making process. Here are some contributions that we made based on AI and machine learning, coming from 5 different European projects. And if you see, there are very hard optimization problems. These are all formulation framework, including RL or a model-based a hybrid framework with a model and an RL hand in hand. And you will see that we can go from local interventions to much more global ones. For example, optimized signalization in the city center of Athens that has more than 1,000 signals to optimize, or even promote specific policies like transit-aware modeling and optimization of traffic, or even dynamic space allocation. So I see the road network as a space, and I want to divide this space and give the space to each mode. according to the policies that I want to implement. And of course, all the issues about fleet management that are not actually networks that operate without any interface with the rest of the traffic. They have a true interface with transit systems and a true interface with traffic. So it's not about fleet management, it's optimizing the mobility or a multi-system, let's say, environment. And last but not least, the interesting thing that Bianca mentioned is that when it comes to stakeholders, we know that they are humans, and somehow we need to bring consensus on the table. Why consensus? Because we know that they operate with conflicting goals. This is a fact. But the important thing is that to test a policy and its effectiveness, we don't have a simulation tool that actually simulates how humans behave when they are to make a decision. So these, we have, in this field, we have opinion dynamics. We have network of stakeholders that is actually a network, a graph that can be developed with interrelations and strength of the interrelations so on. So what we did, we developed actually a simulation framework that was calibrated to simulate the behavior of each stakeholder when they are on a table and try to make a decision. And European Commission, 1 year ago, gathered all this information coming from various different projects, 10 major projects around the EU area, and came up with some directions of study. And you see here that all these relate to how resilient we are in system changes. Let's see the first one. We are not talking about physical infrastructure, nor digital one. We are talking about hybrid forms of infrastructure. And the interesting thing, the challenge is that we have different maturity levels in terms of technologies, but also different aging levels of physical infrastructure. So we have a very difficult mixture of infrastructure based on which we will focus our work. And then the issues of data are not solved because we have approaches, a governance models to collect the data from various organizations, companies, authorities, users, crowdsourcing. But when it comes to bringing all the information together, we are still lacking the frameworks that will allow us to be efficient in collecting, sharing, and analyzing the data. I'm not delving into the details. I can discuss all of this offline because they're also active field of research for my team. This is quite evident because all the results so far from the data-driven approaches, ML/AI for decision-making, pointing towards investing on these technologies for solving all these, addressing all these different KPIs. And the important thing that came up is that now in the European Commission, we're not talking about efficiency, safety, and sustainability. These three are 2 decades ago. We're now talking about inclusivity, accessibility, and resilience. So we came up from the research with 5 different dimensions that we need to optimize the system for. And of course, all the things that I said about stakeholders consensus building. What was quite disruptive was that from all this work and the guidelines and all these policy-making processes, European Commission came with 2 directives. The one is we need to invest in common European data spaces, meaning that we are not talking about cities, let's say, authority, industry, city, region, nation. We are talking about common European data space in EU. Imagine that we will formulate an environment where everything will be pulled inside, multi-domain knowledge, not only mobility, but also you see here energy, which is the evident thing, economy, and all that. And everything will circulate, this information will circulate, and it will be available for everybody. It's a nice idea, but comes with a lot of restrictions. So we are waiting to see how this structure will facilitate the work that we are doing about research and solving problems. But the most interesting thing is the AI Act regulation, which is the first regulation about AI. It's risk-based, meaning that anything that we develop that has AI form, meaning that it's an autonomous unit that decides, we need somehow to categorize it according to the risk it brings on the table for harming humans, for safety, security, and some other criteria. And based on the risk, it comes the restrictions and the restrictions in the development and operation of such AI structures. This is quite significant because it may not affect our research, but it may affect the pathway from lab to market, from lab to society. Because if AI systems become so expensive for an industry to develop, cars, or for a small SME, smart applications or a smart controller on the signal, then we will not see this penetration of such technologies on the system. And according to this AI Act, if it was to implement today all these subsystems that I showed you that we have developed on simulated environment, then we will have a high-risk implementation of AI, meaning extreme cost for taking this idea to the market. When this came around 1 year ago, we start thinking of what is the true contribution that we make in the communities by delivering such complex solutions. For example, an RL, a central structure that can optimize signal timings in the city center of Athens, according to some criteria. What is the true impact that we make if we are not to see this truly operate? But when we were discussing this in our team, we understood that there's a continuous increasing gap between scientific achievements and real-world application. So what we do on our labs or what we publish on their papers are very difficult to go into market. And there are 3 questions that we need to address through our research. Is AI truly applied in traffic management? Are AI-based systems in traffic management of a high-risk application, or AI is a threat? For the first, for sure, if we check the reality, AI is not truly applied for traffic management. We are far from being a high automation or something like a self-organized system for taking decisions about orchestrating traffic and mobility in a city. Actions, prioritization of modes, communication between different traffic management centers or authorities is done manually in the European level. I think that it will continue for some decades in the future. When we discuss with authorities, we see that there is a lack of trust on data-driven insights. So we saw the model, we saw the results, they say, it's quite impressive. But when you ask them, are you going to use it tomorrow in your desk? There's a problem. And if we delve into the details of the applications that are out there, because operators rely, or at least see in their dashboard, some predictive analytics or the result of an optimization algorithm. If you see the details of this AI Act, you will see that the application that you have is not they are sparse. They are narrow procedural tasks, or all of these categories that the exemptions of the AI Act discusses. So at least we are not at the high-risk phase right now. But potentially this is this can come in the near future because AI for traffic management may result in high-risk situations. If you have a system that decides by itself what traffic management plan should I apply given an incident that I will bring on the table based on the algorithm, then you have a high-risk situation. Okay, because there are these boundary conditions, this error term in our models that result in these boundary conditions that are safety critical. So, this is the domain we are looking for right now, which is the trustworthiness of these AI systems. And the interesting thing is that we in our research, we have dealt with trustworthiness in various steps of the process, for the data, for the models, for the decision-making process, but overall, there's no standardized way that can deal with the life cycle assessment of these structures. And this is quite important. And this is not a scientific work. This is a work that needs to be standardized. So the science that we do around this problem is very important. And now I'm getting to the philosophy of my team. I will go fast, but I want to just tell you that we are working more than 20 years on this type of problems that demand data-intensive processes or rely on machine learning algorithms or something that seems to be AI or NRL algorithms and so on. And we continuously return to the basics. For example, when we did statistics or econometrics in the university, this was the key message. Causality matters. I will take the example of short-term traffic forecasting that says, are you sure you are not detecting spurious correlations? Because what I want in a city that I have full, let's say that I have the full observability of what is going on in terms of flow, I can use information from many various places and devise a model that's quite capable of understanding spatiotemporal patterns and predicting well traffic. The problem is that we don't know which causes what, and if we can find what is the cause of the things, we can know the locations where to apply the traffic management strategy to mitigate the congestion effects or reduce the risk of having something that is beyond normal conditions. We have developed a neural Granger model for causality detection. What we saw from the 400 locations that we have data, we only use 4 locations to predict with the similar accuracy as in the saturated, let's say, model. And this is quite interesting because I know I can predict in a location what will happen, and I also know the 4 locations, the 4 entrances in the city that I can intervene to mitigate this problem. So this is very easy, very basic, and if you combine this with powerful tools, ML or AI, it's impressively fast. And what is impressive is that if you jointly consider multiple different predictions coming from various models about traffic variables, for example, volume, speed, occupancy density, and so on, you combine this information in what we traffic engineers, we say the fundamental diagram, you will see that on average we are going very good. But if you combine this information, you will see this behavior. And what we see here, the gray, which is the true conditions, the real, let's say, data, and the dark one, which is the forecasted conditions. What we see is that the model, regardless of its complexity, we have used all the types of prediction models that are out there. Regardless of the complexity, the model cannot fit congested patterns, which may be recurrent or non-recurrent. And we didn't know this because if you only observe one variable, it's good. But if you combine them, it's lousy. And here we have a typical problem, an imbalanced dataset problem, because non-recurrent conditions are very few with respect to what we experience every day. And some will say, I will increase the complexity of the model, a graph-based, all the information that I have. I will also integrate information about power supply because it is related to mobility patterns. And I will correct this, but it's not corrected. What we did, which was quite easy and theory-driven, is that at the loss function, this is a multitask model, meaning it predicts two variables that we want. And at the loss function, we steered the error correction process towards what we know as the anticipated behavior. So every time I get a prediction, I calculate the error, but I also know what is this distance from the anticipated behavior. I try to steer the model toward this form of behavior. And see here what was the effect of this very simple change in the loss function. And I say here that it is simple, it is fast, and it is transferable. This logic can work in any location on the network, regardless of the geometrical characteristics, regardless of the demand characteristics, regardless of the modes that you operate. So impressive, simple, and fast. Of course, we know the predictable part, but there is always uncertainty. It's the things that I cannot predict for various reasons. I can use this uncertainty to correct my process because I know as a modeler that there is not a single model that can do the work. Not even an ensemble of models can easily track all these non-recurrent conditions. I need the human-in-the-loop approach. Yes, I need, because operation in traffic management centers acts like this. There's a human that decides whether to rely on a model or not, eventually. So, given that I want to construct this human-in-the-loop, I can use uncertainty to know when to trigger this, to get the human to act. I can devise a space of actions, change the model, use a simple model, do not rely to a model, but rely to the best model in the world for generalizing unseen conditions, expertise. So if I know all this, I can use this formulation to facilitate the operator to make some decisions, keep him in the loop. We are now in the process of constructing focus groups and trying to see what is the reaction of the operator with respect to this human-in-the-loop process in terms of acceptance and trustworthiness. Last but not least, we are talking about large-scale applications, RL algorithms here is the extended Athens area. Here is the perimeter of the extended Athens area, the city center, let's say. And I want to control the signals in such a way that I have the conditions inside the network at a certain level of service, but also do not impose a congestion at the boundaries. Okay, this is a typical perimeter control problem. I can solve this with RL, with a centralized approach. It's quite time-consuming, but I can do this. But there are decentralized ways to do. Multi-agent frameworks, it will not learn, because it's too data intensive. So I can use the centralized controller as a supervisor to facilitate decentralization. And this is a simple trick to do multi-agent frameworks, and it is not increases the complexity, it has equal performance and the centralized controller. So, as a closure, we know that AI has certain complexities and certain problems when we try to apply, but it's definitely not a threat. For us, it's an opportunity, yet there is a huge research in trying to integrate and automatize processes or induce autonomy in how we manage mobility. As a community, we are trying to keep pushing for integration because, again, all these are research pathways for us, better and more data to account for biases. This is a very important topic because all we discuss right now are data-driven. If you don't have good data, representative data, results will be biased. And this is the first thing why European Commission imposed this AI Act. Auditable systems, for sure. And of course, the intelligence, with the help of technology and connectivity, should go from the user to the system and the process and back to the user. If this loop does not close, then intelligence is not, let's say, what we expect and we assume in the modeling. We are just getting started because the importance of working hand in hand with policymakers and legislative bodies at this stage is very important because we can do a very nice kickstart with AI in cities. But if we do not do this correctly, we will not have the impact that we want as a scientific community. Education and upskilling is top of the list. We cannot expect for the users and the authorities and the stakeholders to understand what we are saying as a scientific community. So here is a huge gap, let's say, that needs to be covered. And of course, always align science with societal challenges. This is the motto of our laboratory because what we are doing, we engineer solutions for humanity. And we do this because it's impactful, it's fun, it's fulfilling. Thank you. Sorry,
very interesting
okay.
Work, very comprehensive presentation. So, are there any questions by the audience?
Excellent work, and I really liked all the four presentations what they bring together. I showed in one slide, which I was really impressed. You said that traffic management, if I remember well, was about efficiency, safety, sustainability. This is what we've been doing all these years.
Inclusivity, accessibility, resilience.
Okay, and then the resilience. I'm going to stay in resilience because obviously you're talking about the resilience of systems. From my understanding, my full understanding is that we're putting a lot of emphasis on the end user, the drivers. Everybody wants to drive fast and drive comfortably. So looking at Professor Smith's presentation, you had a very nice application where you identified the defects on the road. On the roads. I was thinking about it, probably it's a good opportunity, bringing all the presentations from yesterday together, to look at the resilience of the infrastructure. So, for example, it could be, obviously we're looking for optimization of traffic to enhance the experience of the driver, but what if this is not good for the infrastructure itself? Because it might, for example, put a lot of stress in one particular bridge, and then we are paying a lot of money to do the maintenance of the bridge. So it would be a very good opportunity to look at the bigger picture. For example, we look at the risk management. First of that stock, it would be nice to put a high wall, but what is about what's the effect of the traffic? Look at the utilities and the roads, and so we should take into account or look towards the infrastructure itself. Look at the road as a structure. It has materials, it has layers. What is the problem that creates all these potholes, all these cracks? Is it the traffic? Is it the climate change? Because this workshop is about climate change. What if we stress certain areas because of the optimization of the traffic or optimization of the sustainability of the city, and in the end of the day, we're creating more problems that we cannot, let's say, address, mitigate the climate effects. Sorry for the long question, but
so it's nice to have problems because we will have work and we will try to solve them, but you are completely right. This is the approach that we follow in the civil engineering school between different laboratories. So what you saw here is operational resilience, mobility stuff and so on, and some hints of modeling resilience, which is quite important now because we are playing with technologies, we are playing with data-driven approaches, so we need to be resilient in all the ecosystem of involved, let's say, modules, subcomponents of the system. With Professor Van Vatsikos, we have projects that they are dealing with the infrastructural part, and we take from them input, and we try to devise policies and actions of how to deal with the other part of the equation. But this is the starting point, and why we introduced this, you were yesterday, we introduced this Institute for Sustainable and Critical Infrastructure. This is the argument why we need units, research units that may, how can I say it, see and deal with the entire picture of how would you describe it. I completely agree with you.
Are there any other questions?
You mentioned at some point second bid auctions. How do you use
them? In the very far future, not near, we used to say near, but it's very far, we will have automation, vehicles that, automated traffic, let's say, and there we can devise policies to prioritize specific user groups. This can be based on the value of time of each, meaning that I want to go fast and I have a very high value of time, so I will pay in order to be first in the queue. Okay. But it may hint to platoonings, for example, of special vehicles like freight. I want to have, for a special reason, I need to navigate a platoon of heavy vehicles from the city to the peri-urban area. So I have these strategies that may allow navigate this platoon along corridors that are signalized intersection and so on. So based on this philosophy, we have tested market-based approaches for doing so. I know there are a lot of issues about fairness, equitable, and so on, but okay, this is research.
In my space, there's a question of, there's a lot of trust issues about how to operate the building, and so some companies have started to just make suggestions of what you could do and have it be a tool for the operator that they can take or not. And so there's so many different versions of how AI gets incorporated into even a human-in-the-loop workflow. So how does it work in your space?
You're correct, because the problem here is to try to have a conceptual design of the problem that is quite solid. And let's say generic in a sense that we can take it and apply it to each policy and apply it to different settings, different cities and so on. So what we do is to first construct the network of stakeholders, which is actually a graph that the connections relate to the intensity of the relationship that you have with the stakeholder. For example, if I am Uber, I have intense relations with traffic management center because I want to know the incidents. So this is a strong relationship. And then we have the opinion dynamics, another, let's say, graph-based approach that deals with trying to capture the views and the perception of each stakeholder. You understand that industry has a different view about policies in relation to cities and so on. So based on this representation, we try to combine and create an iterative process that will steer them towards the same space of policy, not exactly the same, but In order to do so, we need to understand their perception, meaning that we have criteria, we have the policies, we have criteria, and we need to know their opinion about all these situations. This is another model. So it's a combination of, how can I say it, conceptual designs that should come together, and reinforcement learning is a good strategy to try to find this common ground of thinking. It's a simulation. We do this in order to see if we propose a strategy and we want to see how easy it is to bring all together. It's not a real, I don't see this as being a real case, but it's another simulation tool to try to understand how easy it will be for this policy to actually be implemented and be successful and accepted and so on.
Any other question? Yes.
Yeah, I have a small question. So we've thought about this too, and I appreciate you definitely observing that inclusion of AI within autonomous decision making is itself risky, right? And I'm just wondering, so the way we think of this is just a decision making under uncertainty, and so one can analyze that problem, look at the trade-offs, the risks. I'm just wondering, how are you thinking about it? Yeah.
I know the two philosophies because I have close collaboration with the US. You have an unregulated approach about AI systems. So we let the system do what it does, as long as we have this framework that can account for this uncertainty, or at least identify the uncertainty behind the operation. And this is a philosophy that it's quite unregulated. And then we have the European Commission that does the opposite. Tell me what the system does, I will categorize this, and I will impose you the framework or the actions taken to identify this uncertainty, have a risk management plan behind it, and so on. So I guess that the one is a bottom-up procedure, the US procedure is bottom-up, meaning I develop the system, I see the problems, I will try to fix it. And the other is the top-down. I know beforehand that there will be issues. Present me the system, but also the framework to mitigate issues. From my scientific perspective, I would like to be in the US side, but you know, there are two different schools of thought. It's in the future to see who will be most successful in bringing innovation in cities, because the question is this: how we will bring the innovation in the manner we operate mobility and have impact in the smart city ecosystem, okay? Because many concepts that we discuss in mobility can be applied for administration, management, and so on. Health, yes, yes. So it's a philosophy that we bring, a school of thought that we need to see which of them will be.
The part I don't, sorry, I don't want to spend too long on this, but the part I don't hear from this European proposal, it's good to focus on risk, but sometimes the benefits can also be huge. Things that you could not have done with AI, you could not do any other way.
Βλέπεις ότι πάει μπροστά και
Yeah, I completely agree with you, but they are stressing the operational part. They are not stressing the innovation. Yeah.
We can talk more.
Yeah, okay.
Any other question? So I have one question. Lenny, you have data in the loss function and this uncertainty, as Andrew said. How about the loss function affects the performance of the AI model and the data?
This is not a question to be answered right now.
No,
yes.
A comment.
Yeah.
And this is about the uncertainty, because loss function actually models somehow the uncertainty.
Yes. So these are quite dependent. These are quite dependent. It's not an easy answer. But from the starting point that we are so much into MSC, measuring accuracy and so on, this step that we do about changing the loss function and actually create impact in the accuracy metric, it's very important. I'm not sure how this should be combined, let's say, maybe a model that is combines both. Yes, but no, it's not an AI, it's a complicated structure that may not be an AI model. Sorry.
Okay, thank you very much.
Thank you.
Okay. So, good morning to everyone. I'm Vangelis Marinakis, Assistant Professor at the School of Electrical and Computer Engineering. I represent the Decision Support System Laboratory. So, decision support is a key area of our activities with applications in different domains, especially in energy, climate-related issues. So, research activities include energy management at different levels, building, city, microgrid, and together with Professor Psaras, who is also the head of ICCS Institute in the university, Dimitris Askounis, Haris Doukas, who is also the mayor of Athens. We are the faculty members from the laboratory. We are a team of more than 100 persons participating in a number of European projects. One of them is Crete Valley, which I select today to present in this event because it's a lighthouse project, which focus on the creation of the first renewable energy valley in Europe. This means at local level, to be able to cover the energy needs in 1 year through different renewable energy projects, not only solar, wind energy, but also biomass, biofuels, geothermal, combined also with hydrogen and many more. So this is an idea that also in the US has been applied first in California. So Europe decided to select Crete in order to apply this idea and create the first renewable energy valley. So our main focus is in the Crete island. So Crete is not only a fantastic island for vacation, but also an area for innovation, especially under energy transition. And in the project, we have also selected other areas in Europe as follower communities, like in France, Ireland, Italy, Portugal, where they will try to replicate some of the solutions that we will develop in Crete. So it's a big team, more than 40 partners. We cover all the energy value chain, the Greek TSO, DSO, market operators, many stakeholders from Crete, like the region of Crete, or an energy community, very active from Crete, Minoan energy community. And in the island, we have defined 4 specific areas in Arvi, Lasithi Plateau, Arkalohori, and Atherinolakos. Are 4 areas with many different characteristics in terms of climate conditions. Arvi is a coastal area, while Lasithi Plateau is a mountainous area. In Arkalohori is an area with, before 3-4 years, we had a big earthquake, so there are many vulnerable citizens due to the earthquake, many of them still living in containers. While Atherinolakos is an area with many activities around hydrogen, so in this area we try to combine hydrogen. So in each one of these 4 areas, we will have new renewable energy projects. With a green color, we highlight the project that we are trying to implement. And then through a digital twin, we will try to collect data from all these projects, from the energy production, from the citizens, which include residential sector, public buildings. So we will collect data from the infrastructure in order then to try to make the matching between production, consumption, and better manage the energy needs, the grid operation, and more through the digital twin. So a big part of the project is the installation of these new projects. A second part is the digital part. For the first part, in Arvi, for instance, we target in a number of houses, 1 hotel, 1 school, and then through a geothermal unit, we will try to use energy to cover cooling needs in the area, in a coastal area, plus PV production to cover the electricity. So in this area, we can see also in this figure, we will have a container which will include all the infrastructure for the geothermal unit. We have this unit in the coastal area, and then through a network to cover cooling needs in a number of houses, as we can see in the map. In Lasithi, we focus on to cover the heating needs using agricultural livestock activities through a biofuel unit. And we will also have some small windmills to cover also electricity, plus agrivoltaics, which is also an innovative activity for the area. So a big challenge for this area is to select where we will install the unit of biogas. Because, for instance, initially we had selected a specific village, but then with the citizens, there were many complaints. So stakeholder engagement is also a big challenge for this project, to make people to understand the value of this project. So we start to analyze different areas around Lasithi, and finally we conclude with a specific village, Sant Haralabos, where we can have the installation of the unit in a distance of around 400+ meters, not very close, but this is the only solution to cover heating needs in one swimming pool plus some houses. In Arkalohori, the focus is on a biomass plant where we will use olive tree trimming in order to cover again heating needs, plus photovoltaics, agrivoltaics, and more. We will have a small wind turbine to install in this area, so to try through small project also to engage the local community. And this is also the biomass district heating, again, an analysis where we will install, considering stakeholders, the local population, the regulation, many things, which is a big challenge. And then Atherinolakos with a focus on hydrogen. There is also another big project in this area, Crave, focusing on the hydrogen valley. And the idea is to expand this project through new fuel cell and also hydrogen refueling station, in order then through electric buses to use energy. So, in terms of the digital part, we are trying to develop many different tools covering different activities. First of all, the planning process. So we use AR application in order to involve citizens in the process for this renewable energy valley planning, and also a REV planning decision support tool in order trying to engage citizens in this process, and also to use data for the better design of all these projects. Other processes around the data, in order to be able to collect data from all this infrastructure and to be able to process this data. So there are many activities around standards, open APIs, and also with data spaces, in order to be able to share data from all these different infrastructure and stakeholders. Other activity, about the architecture, to define the architecture. And another important task is AI, where, based on all this data, to be able to apply AI algorithms, not only traditional techniques, but also modern techniques, in order to enable forecasting, energy forecasting from consumption, production, then grid operation, to have also power flow simulations, in order all these different activities to be included in the digital twin, which will be the final product, let's say, to be used from the grid operators or from the energy community manager. So this is more or less the project. It's a lighthouse project, as I said before, 25 million the budget, and as we see, combine many different characteristics to the installation of all these projects. So there are many, many challenges, and also a big challenge for Crete is photovoltaics, where we cannot install PV. And we are trying also with the ministry, we didn't find a solution, to have the support to enable the installation, let's say, of 1 megawatt. The target is 3 megawatt, but we will see. And also for the other units, there are many challenges around the regulation. So we are trying to address these challenges. So one big challenge is the regulatory framework. Other is with the stakeholder engagement. So there are many, many activities to engage the local community, to facilitate them to understand the value of this project and participate in the energy community and actually benefit from the energy production. And of course, then the technical, the digital part, which of course through the university, we have a key role to develop the relevant algorithms, models, to simulate the local conditions, the grid, and many more. So happy also to see other opportunities for collaboration in all this field. So this is the presentation from my side.
Very impressive work on energy efficiency and photovoltaic renewable energy. Thank you very much. So, are the status?
There is a presentation project. Have you considered any storage? Big issue in energy storage. How to store it?
Storage. This is also a challenge.
Have you considered in this Crete Valley any storage requirements or how you store the redundant energy?
Storage is also a part of the different activities. We will also have some batteries, either, for instance, in the PV units or locally within specific buildings to have photovoltaic battery in specific houses. So one way is storage. A second is through hydrogen, in some cases to use hydrogen also as storage to use later the energy that we can have from hydrogen. So, of course, storage is necessary in order to be able to increase the autonomy within the area. Because, okay, you know, photovoltaics, we have specific hours from energy, but then later we may use storage to cover the needs. And the target of the project is to achieve energy autonomy in 1 year basis. But ideally, within the day, to increase the hours of autonomy for the houses, buildings that we target. So we combine different renewable energy projects plus storage to increase this autonomy. Πολλές ερωτήσεις.
Well, very nice project, very interesting. I'd like to ask, when this project has started, what is the process or development of the solutions that you described?
Good question. This is a 5-year project. Okay. We started around 1 year now. So we have 4 more years, and the first 2 years is the design, installation of this new project. So first part is the installation. After the first half of the project will be the application of the digital part.
I'm asking you this is because if we can adapt and replicate the solutions that you will develop to be applied to a different pilot case.
End of the project.
Namely, the campus of NTUA. We have a large, as you know, problem with electric demand.
We need an energy community for the campus.
Yes.
And together maybe with Athens to combine them.
Yes, we have started discussing this. We plan to install photovoltaic systems here in the campus, but also combined with other solutions that you probably developed.
One option Yeah, from the project we can use many digital technologies. But also through the city of Athens, we can have this synergy and exploit the way to have these installations. And for sure. Because we have also mayor from the university. Very interesting.
What is the limiting factor for scaling up? For example, from what I saw, that it's a pilot case, as you
it's a research project. Yeah.
Do you see any particular limiting factor for scaling up to a city 10,000 people? Because we're talking about 300 or 400.
Yeah, this is a research project, so we provide a pilot to be able to test that the solutions can be feasible. The scale of the project is in total around 350 households, buildings. Of course, then this can be replicated and expand to a bigger area. In general, the concept of renewable energy valley is in a local level, in a specific area, try to cover the energy needs from different renewable energy projects in order, let's say, to don't use grid and only through renewable, locally produced to cover the energy needs. To achieve this, it's not easy. So maybe this is a starting point, trying in small villages to justify that all these different projects can be feasible and then to upscale this. Because, for instance, one of the projects in Arvis with geothermal, where we use the water from the sea to cover cooling needs in buildings around the sea, the coastal. One challenge here is that only through houses, it's not easy to have business value, because you need also big consumers, like hotels, where they can pay some money for the maintenance of the unit and to be this feasible. Otherwise, if you have only houses, it's not easy for a resident to pay, let's say, €100 for the cooling needs to use this system. I mean, the business model, in order to upscale the solution, needs some limitations, some specific parameters. So, in this specific case, for instance, if we have an area around the sea and focus on the geothermal, this is a very good solution because you can increase the cooling, to cover the cooling needs. But for the business model, in some cases, for instance, you may also need big players like hotels to invest in this action.
That's why I guess I mentioned 3 or 4 cases to make guidelines, let's say, but
exactly.
For
Exactly. This is part of the, we will have business model exploitation part, but later in the project. Please.
It's a very interesting model what you presented. Are there any other similar projects worldwide? There must be similar projects where you already have results. What is the optimal mix from the different energy technologies and all this that you have applied here? You don't start from...
No. In the second slide, I saw also an example from US, where in California, there is also a renewable Silicon Valley case. And in general, again, they have the full area, specific projects, and they try to combine this project. For instance, in California, there is a specific case with type of project, but I think we have also to consider local needs in other areas, like Crete, because, for instance, California, Crete, very completely different cases. So there are some examples, like in US, and I think now we need to see also in Europe, especially in Crete, in our island, how this can be applied, and maybe to have also results from Europe. The ladies, because to keep also the gender balance.
Local area depends on the demands, and was in the first instance for the 4 different locations, how did you decide which technologies would be where?
Good question. First of all, the areas, there was also a process to select the areas because we tried to combine areas with many different characteristics, mountains, areas around the sea, and many other things. So one process was to select the areas. Then about the projects, we consider the available resources within these specific areas. For instance, Arkalohori, we proposed biomass because there is available resources around biomass like olive trees trimming. So there is a lot of resources which then we can use to supply a biomass unit. So to select the biomass, somehow this was the process. Next step is to define specific where we will locate the biomass unit and this feasibility study in order at the end to have a project that can be feasibly implemented, to have a specific business model and bring value to the local economy. So for all the projects, there was a process first to select the locations. So because Crete is a big area, and of course we cannot say that we achieve energy autonomy to the full island of Crete. To select the locations, we use specific criteria, parameters. Then, since we select the location to define the type of projects, we consider the available resources, and then we proceed with the feasibility study in order to have specific parameters for the installation of this project. And next step is the digital part, where we will have all the information, all the data, to collect data, and on top of this data to apply AI, you know, all the algorithms and simulation models for the research activities. In all this process that I described before, we had also stakeholders in this process, especially citizens or the local authorities like the municipality or the region of Crete. So we had many events, local events, bringing citizens to inform them about this project, because as I said also before, in some cases there were complaints that, okay, I don't want biomass in my area, or many other things. So we had many different types of events in order to engage citizens, understand the value, and then make them to participate in these projects through the form of the energy community. And one important aspect was that we have already on board the region of Crete, the energy community of Minoan, which is already active. They have already renewable energy projects before Crete Valley, so they have the experience. They have the connection with the local citizens, so they facilitate the engagement of new citizens and all the process to participate in this program. And although we are a one-year project, we have already secured citizens who want to participate and become member of the energy community and benefit from the energy production. But we have delays due to the regulatory framework for the ministry to address some activities, some things. Yeah, first ladies.
Year now. About the licenses information, how long did it take for you to get them? And about the PVs, you said you had some issues with the licenses, and I guess you're still working on them. Do you believe that you'll get them soon? Because you said that you want to work on this project for 5 years, but there might be issues with the licenses, as you said.
Yeah, in general, for the license process, in the project, in some cases, this can be more than 1 year. I mean 6 months, 1 year, even more. But we are trying to push. We have the regulatory authority also on board, and they help us. For instance, we have secured the license for the biomass unit. So, in general, we have a good collaboration with the relevant national authorities for these things. Also, on board, we have the grid operators, the regulatory authorities, so the key players to facilitate this process. So I hope we will be able soon to finalize the license process. The main challenge is about photovoltaics because for the Crete island, it's a big story for Greece due to limits in the capacity in terms of new installations. I hope also this soon we will have a solution in order to proceed with the implementations. So, as I said, it's a big challenge. We need time, but I hope in a 5 years window, we will try to solve this. Please.
Very interesting presentation. I have a question. Are these communities outside of the grid, or are they connected to the overall electric grid of Crete?
The energy communities from Greece. In the island of Crete, there is an energy community. This is also the biggest energy community in Greece, Minoan, with more than 1,000 citizens involved. They have around 5 megawatt projects in Crete and also Peloponnese. So they are energy community within Greece, in Greece, and they are working based on the Greek regulation.
Are they connected to the electric grid of Crete?
They have...
The island of Crete has its own electric grid.
Exactly.
Yes. Are they
the energy community has renewable PV projects in the island of Crete and also in other area, Peloponnese. So they provide the renewable energy project. Then the connection with the grid, this is something based on the grid operators, the DE, ADMIE, who manage the grid operation.
Yeah, but this is a community, it has certain people living.
Exactly.
So is this community outside of the grid? They rely exclusively on the renewables?
The community is part of the grid, of the national grid, especially the grid of Crete. If I participate in the energy community, then based also on the model of net metering, based on my consumption of my home, I have the matching with the production from the energy community.
Since they are a part of the grid, and there is always opposition from local communities about installing very close to their properties different renewables. Why not go a little further away? Crete is a big island. In a remote community where there are no people living around, install the renewables there, connect them to the grid, and supply them this way. There must be a reason, but I don't know why not.
This could be also an option, but in Crete, we have defined areas where we can have these projects, photovoltaics, everything, with the support of citizens, after the discussion of citizens. So, an area exists in Crete. The problem is the connection with the grid, because the grid operators cannot add more installations, especially photovoltaics. So it's an issue of the grid operation.
The grid cannot
so the reason is if the grid cannot add more installations to select another area outside Crete for new installation. So it's not citizen stakeholders the problem, grid. Let's see.
This clarifies my question. Thank you.
Perfect. One more. We have time.
I can ask you a question. All right, go for it. Okay, I'll ask quickly. You mentioned hydrogen, and what's the use of hydrogen? Is that as a direct fuel, or are you storing it to then hydrolyze it later?
There's no presentation. For the hydrogen, in a specific area, there is also a previous project from Crete Valley, CRAVE, which focus on a hydrogen valley. So they will install the electrolyzer, all the units, and then the idea is, for instance, through fuel stations, to supply buses, hydrogen buses, which is under a tourist company, in order to use buses within the area. Other option could be to supply also the grid when we need the energy, so as operating, let's say, as storage. So it's different ways that they are planning to use hydrogen. But again, this is something that the upcoming period we will have more results, because now they are trying to address again the legislative issues. Also in Greece now we have a new legislation about hydrogen, which is also important in order to facilitate the installations of the different projects, which is under διαβούλευση, negotiation.
Okay, thank you very much.
Thank you.
Okay. So, I'm very happy to be here to present actually what I'm going to present today is the new Circular Economy and Sustainability Institute of the National Technical University of Athens. And I'm particularly glad because it's a very new institute. It has been founded 2 months ago. There was many months that we have collaborated with Vice Rector Manos Varvarigos, and now it is there. So it is our first presentation. And actually, what is the need for the new Circular Economy and Sustainability Institute of NTUA? The purpose that we created it is that each of us, all professors of NTUA, we have our own laboratories, research units, and so on. Many of us work in the area of circular economy and sustainability and towards green transition, circularity. But all of us see and focus on a specific area, on a specific research area. So the need is to have an institute that will solve complex problems, problems where you need interdisciplinary collaboration. And this is why we started SESI. The mission is to promote circular economy for sustainable development through applied research, education, and the dissemination of scientific knowledge. We are 20, up to now, 20 founding members, 20 professors that cover all the schools, all the 9 schools of NTUA, and each of us complements the others. We have here the different areas where we focus on. It is circular economy and resource utilization, digital systems, networks and smart infrastructure, transport, shipping and logistics, spatial planning and development, environment, climate resilience and water, materials and advanced applications, energy and thermal technology. So you can see that there are different areas, but for some projects you need the collaboration, for example, from a specialized researcher that works in digital systems and networks, from the electrical engineering school. Or there are many problems in shipping that deal with the environment. The new emission trading system gives us opportunities for work and new projects. So this collaboration is essential. Here you can see, I will do it quickly because we have a limited time, but I just want to give you a picture, an overview of what we are doing. So maybe, and it's a very good opportunity to be here today, because maybe we can have a collaboration also with Columbia in these areas. Concerning circular economy and resource utilization, there is waste management. We are dealing and we are talking about zero waste systems and optimization of waste management systems. Valorization of agricultural and industrial byproducts via advanced bio-based solutions, life cycle assessments, digital twins for tracking material flows and enabling real-time optimization of resource use, sustainable product design. All these derive from the data and the projects that we have gathered from all the founding members, the professors that comprise this new research institute. I will go very quickly. Digital systems, networks, and smart infrastructure. There is integration of AI in many projects that you need that. Digital twins, as I mentioned. Data sharing architectures, 6G enabling technologies. Concerning transport, shipping, and logistics, here you can, there are projects and there is a need for optimization of multimodal logistics using AI. There is experience in all this that I present today. There is experience from the different professors of NTUA, and so we can combine this experience in solving specific problems. Decarbonization strategies, something very important. Intelligent transportation systems, autonomous and remotely operated vessels for next generation shipping, which is a hot topic, supply chains resilience and traceability using digital ledger technologies, spatial planning and development, here smart and inclusive urban design, they are experienced colleagues in this, integration of nature-based solutions for urban planning, geo-AI application in land use forecasting and environmental risk mitigation, urban metabolism modeling for circular city development, something that we can also discuss concerning smart city research, and policies and tools for adaptive spatial governance under climate change scenarios. Environment, climate resilience, and water. Again, climate adaptation modeling and scenario analysis techniques. Nature-based solutions for flood risk management and ecosystem restoration. Advanced hydrological and hydraulic modeling for water resource management. And again here, remote sensing and AI for environmental monitoring of specific areas. Again, I will be brief. Materials and advanced application. You can see here that there is a lot of expertise in the different materials, sustainable composites is an example. Then energy and thermal technologies. There is a research, and there was also the previous project is an example of that, hybrid renewable energy systems and energy storage optimization, thermochemical and electrochemical energy conversion using sustainable fuels, district heating and cooling networks, hydrogen technologies, AI-driven energy management, and many other. So what are the principles of the Institute? First of all, interdisciplinarity. This is the most important factor, and this is why we have the Institute. We all have our projects with our own units, research units, but there are many cases where we need help from others. If you take into account that there are 20 founding professor members, and each of them has, let's say, 20, 30 persons working in their lab, so we have actually a capacity of 500 people, even more, that can work together according to each project. For each project, there will be a scientific responsible who will be the one that knows the project well, but he will work with 2, 3, 4, 5 of the other professors of the Institute. Collaborative networks, this is the idea, and innovation and open science in order to have also real-world impact. We have to go out not only in Greece, of course, and in the EU, but also worldwide. The activity and goals are conducting research, policy development, implementation of circular economy principles, and promoting innovation. Also, networking and participation. We have our network, but we want to create a network not only in Greece, but in the EU with similar institutes. We have already started with some well-known institutes in the field. And also resource mobilization to strengthen the capacity of NTUA and to have high-level research, high-quality research, but big projects, where in some cases it's not possible with our research units to have success. And also advisory services. Who are the founding members of SESI? Let me start with our research unit, which is I am the UNESCO chairholder on green innovation and circular economy at the School of Mechanical Engineering. I will give you 2 exemplary projects because I know them well. For the other colleagues, you will just see some titles and some of the projects they are involved in, and you will see how many projects we have at NTUA in the different fields and in the different schools. I think it is a very good overview that we have gathered them all together, and somebody will see how high is the quality of research at NTUA. Now I'm focusing on green innovation, green research, environment, but obviously it's also the same in other areas. So we focus at the UNESCO chair on research, education, and knowledge transfer in green innovation and circular economy, with emphasis on business planning as a driver for sustainable economic development. I will give you some examples of some indicative projects that we were involved in. Water-wise hub, Professor Makropoulos, we collaborate with him, has presented it extensively yesterday, so you know this. It's a circular regenerative water management strategic initiative for different countries of Europe. CHO, there it is a Horizon project that demonstrates how surface, ground waste and process water can be jointly managed to prevent scarcity and pollution and boost climate resilience. Gaia, this was a very interesting project that is in progress. It is a young entrepreneurship scheme expanding green tech, Greece's Green Tech Challenge across Europe. I will refer to Green Tech Challenge in the next slide. It is, I will tell you what it is. It is actually an innovation challenge, a green innovation challenge, and it's actually the biggest green innovation challenge in Greece, starting from the NTUA 8 years ago, and it has become the biggest in Greece, and I will show you some details after in the next slide. Impetus, it is a project creating resilience knowledge boosters, and where all stakeholders can take part. Another life profile is, has created robust risk assessment tools to ensure funds are available to prevent, detect, and remediate biodiversity, water, and land damage, and also forest fire. An online collaboration platform, mobile app, and training program to share best practices for managing Natura 2000 forest sites in Greece. I will just refer and give some more detail to Green Tech Challenge that I mentioned before. It has started 2018, and its goal is to bridge academia and industry. We have 20 industrial partners that support it, the biggest companies of Greece in the area of energy and environment. And what we do is we want to, here you can see, it is also in a collaboration with one of our courses of the at Mechanical Engineering School. It is a 3-month program. It engages startups, researchers, and students to develop and present sustainable innovation. So it has already been organized 8 times. And actually what it comprises, it is a group has an idea. We help the group, a green idea, and we help the groups to develop the idea into feasible business plans within a 3-month period by organizing also workshops where we invite also executives from the companies, the 20 companies that support Green Tech Challenge, to give a presentation of where there are market niches in their area, where they operate, so that the groups develop ideas in this area. Just some data. There were over 1,000 hours of training, 2024. There were 35 participating startups, because we have not only groups that start from an idea, but also startups in a different scheme. And we have 22 participating researchers, because there is also another stream for research laboratories, where last time there were 22 laboratories, mainly from NTUA, that have taken part. We had 283 participating students and innovators, which is quite high, and over 100 mentors that take part the different years that we have organized that. It is a success that we have Elevate Greece in Greece. Elevate Greece is the registry of the startups in all different areas. In the area of environment, 1/3 of the startups has come through Green Tech Challenge. So for us, it is a success. Here you can see a picture, slide from the recent Green Tech Challenge. Now, another project that is interesting that I would like to present to you is a carbon footprint and carbon avoidance project, where we have recalculated and re-verified carbon footprint projects, renewable energy projects in India. And then we have developed a meta-registry which includes all the data for these projects. This is assigned by the Greek National Certifier and Verifier Authority, and the goal is to calculate accurately and reassess the carbon footprint and the carbon avoidance of these projects in India. We went also in India. We have inspected these projects, and according to ISO 14064, and these are the two projects, a 77 megawatt bundle-wide project and a 4.9 megawatt small hydroelectric projects in India, all of them, in different areas in India which we have visited and inspected and gathered all the data. And we have calculated the greenhouse gas emissions according to the ISO for the different scopes, scope 1 and scope 2. Here you can see direct emissions. We have calculated, but also indirect emissions according to the ISO. And here we have calculated, for example, in total around 800,000 CO2 tons. And we have calculated what is the avoided emissions from that. And the same we did with the hydro project. The same has been calculated, and then we have created a meta-registry at the NTUA. There is a registry in India, but the advantage of our meta-registry is that it is an EU registry, which has all the data. And you know, you can use these carbon credits that are recalculated, and they are also according to ISO, and the Greek company Mirtek, which is the official national accreditor company, has accredited these projects, so they can be used in the informal offset carbon credit market. So it is something interesting, and that is why I'm presenting it here. You can find all the details in our site. We have also aligned it with the 17 Sustainable Development Goals, and also we have all the data, the inspection date and the certificate number for each of them. Here you can see this in our site. Now, I will briefly present to you all the members of our institute, very briefly, some indicative projects, so you will see what kind of projects they are. I will not go into detail, but you can see the wide range of projects and areas that are covered. Professor Baltas and Professor Malamis, School of Civil Engineering, they focus on water. And here, an indicative projects list, you can see from the School of Civil Engineering that these colleagues have sent us to have it in our profile, let's say, institute's profile. You can see that there are projects that aim to strengthen climate and social resilience in rural areas. There's a project for climate adaptation and resilience demonstrated in the Mediterranean region. Cardimed. Theseus is a first of a kind hub for circularity demonstration for Attica and peripheral regions. It is an integrated circular economy hub to demonstrate zero waste, something that is in the core of our activities as an institute. Another project accelerating water circularity in food and beverage, and which promotes industrial water reuse and circularity. And another project that demonstrates water loops with innovative regenerative business models for the Mediterranean region. At the School of Mechanical Engineering, there is also Professor Redizelas, professor who is together with me at the chair, and Professor Rogdakis, together with Professor Koronaki, who is here, that deal with thermodynamics, heat pumps, thermal engines. They put an emphasis on energy efficiency. Professor Koronakis will make a presentation, is the next presentation, so you will hear from herself. Activities include applied research, energy audits, and energy systems optimization. And of course, the laboratory is of applied thermodynamics and refrigeration. And tomorrow, after 2 days, is the refrigeration day. Tomorrow, yes. Okay. Professor Koulocheris from the Vehicles Laboratory, high power installations, compatibility testing in specialized environment. Again, there are environmental issues also in this area, and Professor Koulocheris works already in the area of circular economy. Some indicative projects from the School of Mechanical Engineering you can see here. I don't want to go into details due to lack of time, but you will have the presentation, and so you can have a closer look at this. There are many projects. You can see the wide range in the Mechanical Engineering School. Also buildings, energy building savings and so on is an issue, and energy storage, something very important that deals with circularity. Circularity is not only, some people think circular economy is only waste management. Of course, it's not only waste management, it's also energy optimization and resources optimization, but it is also zero waste, what we call. And all this within sustainability. And what are the directives of the EU concerning a green transition? Okay, this is the emphasis that we put in. In the School of Electrical and Computer Engineering, Professor Papavasiliou and Assistant Professor Stai, all different issues that deal with design and management of complex and dynamic networks, including 5G, 6G, smart grids, IoT, all the different areas. And Professor Gonos, who deals with high voltage and electrical measurements in his laboratory. And he has also an accredited, according to ISO, facility for high voltage and photometric testing. What is important is that in all projects, all environmental projects, we need also IoT, we need environmental technology, and this is actually the great advantage of having such a diversified group of researchers and research groups. Here you can see indicative projects. Arsinoe is a very well-known project, a Horizon, very big Horizon project, where they built climate resilience pathways using a systems innovation approach and climate innovation window, enabling stakeholders to co-design solutions and bundle new or existing technologies for climate change adaptation. And all other similar projects that deal with digital tools from the Electrical and Computer Engineering School. The School of Architecture, Professor Alexandrou is one of the founding members. The laboratory is the Laboratory of Building Construction. Again, architecture is also a part when you design an environmental system. There, she deals also with energy efficiency in buildings, cost-optima performance standards, and urban sustainability strategies. Again, here you can see indicative projects from the focus of the architecture school. School of Chemical Engineering. It is Emeritus Professor Andreopoulos, an ex-rector of NTUA, from the Laboratory of Polymer Technology, and Professor Krokida from the Laboratory of Process Analysis and Design. All different projects focusing on not only on polymerization and special materials, but also development, modeling, and optimization of chemical and biochemical processes. Here you can see some indicative projects, all kinds of projects. I don't want to go into detail. From the School of Rural Surveying and Geoinformatics Engineering, there is Professor Bakoyannis and Associate Professor Hadjichristos. Especially sustainable mobility is an issue. It is the specialization where Professor Bakoyannis focuses. And their urban and spatial planning integrated with sustainable mobility practices. Actually, Professor Bakoyannis is also the Secretary General for urban planning nowadays in Greece. So it is very good. We are very happy that he is with us. And here you can see different projects concerning land planning, urban optimization, and so on. And at the School of Mining and Metallurgical Engineering, there is Professor Anastasakis, who works in the area of mineral processing, separation of minerals and solid waste, and waste management, using different properties and different technologies. And here you can see indicative projects. I don't want to get into detail. School of Naval Architecture and Marine Engineering, Professor Grigoropoulos from the Laboratory of Naval and Marine Hydrodynamics, Associate Professor Lyridis from the Laboratory of Maritime Transport, and Associate Professor Ventikos, who is here present, who has the Laboratory of Ship Design, the Maritime Risk Group. There are various projects actually that are also interdisciplinary from the marine area, marine optimization, and especially ETS, which is an issue, the emissions from the marine emissions, and the energy management for ships. And you know, Greece, the biggest industry in Greece is actually the shipping industry. So there's an area where maybe we can do also interdisciplinary research. Here you can see some of the projects that the members of our institute already have experience, wide experience, and I think the School of Naval Architecture is the leading school in Greece. Okay, so actually all areas are covered. And last but not least, the School of Applied Mathematics, Mathematical and Physics Science, Professor Papagiannis, who works in the Laser Remote Sensing Unit with LIDAR systems, atmospheric pollutants, bioaerosol specification, and so on. And here you can see some indicative projects also from this school. Coming to the end, I would just like to emphasize that with this new institute, we hope that we will have the opportunity to get also into competitive projects and especially create networks, worldwide networks with similar institutes all around Europe and the US. So Columbia is a very good case that maybe we could have a cooperation and handle large-scale projects of a complex value and type. Thank you very much.
The connection with other schools of NTUA that got emphasis in research of NTUA. Thank you very much. Are there any questions to discuss about? Yes.
I didn't know about this. The institute is very, very impressive. But from where are you receiving the funding to support all these different projects? Is it European Union, the Greek government? Where is the funding coming from?
This institute is a new institute. It's only 4 months that it has been created. All these research projects that I have presented are projects that come from the founding members of the Institute. These were funded by different sources, national or international or EU sources. What we are going to do is, actually we don't get any funding from NTUA, but since we have all this experience and the size and the ability to try to get big projects, this is our aim. We will build, and we have already built a network. We already speak to each other, so that is why this is actually our first presentation of the Institute. What we want to do is, with each of the partners of the Institute, we have 2-3 different areas of interest where we'll put an emphasis. And there, we will apply for research projects. We will make some contacts to big players that would be interested in collaborating with us, like ministries, like big national or also international bodies, like other institutes, like Fraunhofer Institute. We have already agreed to have a collaboration and so on. So this is how we are going to work to get funding.
The only support it gives to is that half of the overhead that these projects give is going to go to the institute itself. So that's all. So the more successful they are, the more funding they have by getting this part of the overhead. And I believe that, do you have corresponding centers in Columbia?
Yeah, there are institutes, there are centers. Usually the centers are funded by the federal government, like Andrew Smith Center on Smart Cities. Institutes are closer to the institute here. Essentially, it's a group of faculty with similar research interests that group together. Sometimes they submit proposals, 2 or 3 together. So there are different types of activities. Yes.
Any other question? You have one?
Me?
Yes.
No question.
No.
Just statement. For the Greek Tech Challenge, I have participated 8 years ago in the first organization. I was not professor, just PhD holder, and it was a really nice experience, very helpful, because I remember it helped me to present better, to make better presentations, so it was a very fantastic experience. And I think also for the students of the school, for engineers, it's something very important, because they can help them to increase the skills on how to present activities, projects. Exactly.
Very important answers. And I hope that the administration of NTUA support these activities. So thank you very much. And the next speaker is
Hello, good afternoon. I'm Irene Koronaki. I'm a professor of a School of Mechanical Engineering. I'm also a mechanical engineer. Today I will present a part of our expert area. Actually, our expert area is, as Professor Konstantinos Saravosis said before, our expert area is thermodynamic analysis and experimental investigation of energy systems that they are used for thermal production and cooling production and also electricity production. But I wanted in my presentation to all of you to give you an idea what we do here in our home, in our campuses. So I won't present you any detailed projects, only what we have started to do in terms of sustainability, in terms of the sustainability strategy plan, actually, that ended a few months ago. So our vision is to focus on sustainability, because sustainability, we want to use sustainability as a strategic necessity. As I told you before, we have conducted the first of a kind sustainability strategy plan of NTUA in 2025. Because we want to be involved in strategies that has to do with SDGs, Sustainable Development Goals, including Sustainable Development Goals in our educational programs, we want also to engage our community to be involved in such actions. We have created a platform, we have created a site about sustainability, it's a sustainable NTUA, and that is because we want to have an institutional role in climate action. Because as a university, as a Greek university, we see ourselves as multipliers. through education and outreach. And we want to prepare our students, our thousands of students, to act as sustainable ambassadors. We want to expand our knowledge to our students, to provide campuses as living labs. All this initiative has started in collaboration with other universities, members of the European Alliance of EU List Alliance. Actually, NTUA is a funding member of EU List Alliance. And as a funding member, we wanted, in collaboration with the other 9 universities, to become better in sustainability, as they are. So we had benchmarking, we have started benchmarking and best practice exchange between ourselves in order to have a global presence on climate action, on improvement of climate action and improvement and inclusion of sustainability in our way of life. As I told you before, we have involved students and also courses, actually courses of mechanical engineering, or School of Mechanical Engineering, have included sustainable development goals. And we have already concluded all the procedure how to do it. And how, and we can recommend to other schools of NTUA how to include SDGs in their courses. Moreover, through the EU list, we have developed our own tool for carbon footprint calculation. Carbon footprint calculations with data from energy meters that we have installed, but also from the data from energy commuting, emissions from students commuting, emissions from cars, from owned cars, and also from some procurement processes. So we have developed this tool, and we know how much emissions each school has. Also on sustainability, sustainability in education, we included sustainability in many courses, many undergraduate and postgraduate courses, and also practical learning through hands-on projects in order to connect this theory with the real-world sustainability. As an example is the living lab that we have designed and constructed in the School of Mechanical Engineering, and it's situated outside our building. This is a pilot building of zero energy consumption. It has movable walls, interchangeable walls, wall component. They are wall component, and we can measure the efficiency, the energy efficiency of these walls, the overall heat transfer coefficient, and we are collaborating with the industry that concerns not only the cell, but also the HVAC systems. Also, this living lab, this pilot building, has underfloor heating and cooling, and systems that they are very innovative. For example, this unit has a reversible heat pump, organic cycle system, in collaboration with in connection with, to an adsorption sealer. By using the biomass unit that it has, it gives to this pilot building not only heating loads, but also cooling and electricity. And our main focus has to be on heat pumps. Has to be on heat pumps because, according to many percentages that all plants give, the consumption of for heating and cooling and ventilating is approximately 50% of the whole consumption for the building. So we have to be focused on heat pumps. And actually, in our laboratory of applied thermodynamics, we have constructed test beds of alternative heat pump, alternative refrigerants like propane, in order to give the idea to our students and also young engineers how to tackle with problems of heat pumps and how to tackle with emissions from refrigerants. Also, these test beds have remote monitoring platforms, and they give the opportunity. They offer the opportunity to the young students and to young researchers and engineers to be trained and to co-design systems like this. Also, we provide practical learning through this laboratory with 3D printers. We have approximately 10 3D printers, and we support full-scale experimentation. Examples like solar cooling units and smart controls are some of the systems that we have included in our courses. Moreover, we participate in international student competitions, and we have won. I'm proud to say this because in collaboration with the architectural school, we have won the second and the third prize of a worldwide student competition of ASRA. ASRA is American Society of Heating, Ventilating and Air Conditioning Engineers Society, and we have won these two prizes. Our students won these two prizes. Actually, the third prize was won last year in 2024, and we had a multidisciplinary student team from mechanical engineering and from architectural engineering, and they designed a net zero building, library building, situated in Sao Paulo. And it was a very challenging thing to do because in this contents there were universities from all over the world. Universities from the US, from Asia, from all over the world, from Europe also. Also, our focus area, which is of course heat pumps, we use all this expertise to extend this knowledge to also engineers for lifelong learning. Through KEDIVIM, through lifelong learning programs, we offer e-learning and certification programs for professionals. And these programs include zero energy buildings, HVAC efficiency, green innovation, and they are programs that they are tailored to current market needs, and they promote a wide impact as the numbers show. Certification training for refrigeration technicians is also something that we want to be involved. We are involved, and this is because refrigerants, the old refrigerants, will be banned in 2027. So we need to focus on new ones with very low GWP. Global warming potential. Global warming potential gives the amount of what is the impact of 1 kilo of refrigerant to the environment. Old refrigerants had GWPs even 3,000. That means that 3,000 kilos, they are the same as 3,000 kilos of CO2 emissions. So now we are focused on refrigerants of GWP3 or GWP1. 1 means that we have CO2 as a new refrigerant in our HVAC systems that we examine. Not only hydrocarbons, not only propane, but also CO2 test beds are designed and constructed and included in laboratory of applied thermodynamics. For the sustainability strategy plan that I mentioned before, we have installed 70 electricity meters all over the 2 campuses, Campus Zografou and Campus Patission. So we have a data-driven energy management system, and the campus buildings are prioritized based on consumption profiles. Also, we have included some renewable energy systems, actually 56 kilowatt photovoltaic panels were installed in the main building, of the rector building. And also we have other installments of photovoltaics in School of Mechanical Engineering, in Chemical Engineering. And of course, these are actions in order to support our carbon neutrality goals. Many renovations have started with sustainability in focus, and older buildings have started to be upgraded by renovation actions. Actually, I give you here an example of our dynamics and naval architecture and hydraulic machinery building, which will be renovated in the current year. It is a building where very new systems will be installed. For example, storage hybrid cooling system. It is a very innovative one. Also, vertical geothermal exchangers will be also installed. This building will be, we would like to be carbon neutral. Moreover, we have started actions for sustainable water management, monitoring. We would like to start monitoring of the water consumption, waste reduction through circular practices. We have implemented some three-tier waste management strategies. Reduce, reuse, and recycle, and also bins in some parts of the whole campus, across the campus, so as to separate streams between paper, plastics, electronics, and batteries. Also, we promote active and public transport. We encourage walking. We have many cycling ways around the area, and also we are about to launch a carpooling platform in order to reduce the use of cars. Another thing that we want to start is the promotion of reuse over replacement, because reuse reduces both waste and cost. So we want also in the near future to promote to our students and to our faculty and all staff these actions. Sustainability education has started, as I told you before, in undergraduate and postgraduate courses. Main focus on SDGs, climate actions, and reduction of energy consumption. And of course, we have campaigns and awareness programs. Awareness programs through campaigns that they are held all over the year from different schools. Challenges. We have very many challenges because of there are a lot of programs, a lot of barriers. Barriers, for example, funding constraints. We have funding constraints. We have buildings that they are old, and many buildings. Actually, in the campus area of Zografou, we have 64 buildings. And the total area of these buildings are 264,000 square meters. Our consumption is similar to the consumption of a of the biggest municipality of Attica, the biggest municipality of Attica, of Acharnon. Future priorities and innovation is, of course, energy management, mobility, expansion of sustainable infrastructure, and we want this plan, this sustainability strategy plan, to be communicated to all our students, to all our personnel, because it reflects a deep commitment to long-term institutional transformation. NTUA sees sustainability as a shared journey, and collaboration with Columbia University would be a very good opportunity to exchange ideas so as to be more productive also in this area. Thank you very much. Thank you.
Professor of Evidence in work and presents to the audience the activities of your lab and the School of Mechanical Engineering in the area of
And of course, with the help of a rector and vice rector, we want to present all this work that has been done to the whole community.
To mitigate the climate change.
To mitigate the climate change, yes.
It's important, it's not only what it's very useful for NTUA. You know, the QS rankings, etc., have 10% related to sustainability. Until last year, we were getting 0 there. We're getting low ones.
Not the 0, but a little bit, yeah.
And that's very important. I mean, we have to communicate.
We have to communicate all these actions to the community, to our community. They have to pay attention. Also, we have started to develop some questionnaires in order to see the commuting, how will be involved in the carbon footprint. Because we have to calculate our carbon footprint as the whole universities of Europe. And worldwide, of course.
So let's start the dialogue between the administration and the academic community.
Yes, yes, yes. It's very important to exchange ideas and best practices that you are working on in your premises.
Can I continue on that? I was going to suggest that you communicate this because it's very impressive work. It's a pity that people don't know about the efforts of the university.
It is actually.
I would suggest that you emphasize mostly with education part, because you saw that you have developed curriculum based on sustainability, you have hands-on training, you have laboratories. Don't focus only on showing that the campus is sustainable and all these efforts. Because what is of value, I think, is that the university is actually integrating these sustainability issues into the curricula, the education, and the new generation of engineers. This is what we should sell, let's say, outside our university. Otherwise, if we focus only on the sustainable campus, which is also a big achievement, it would be okay, another achievement, another organization that became sustainable. No, we are a university, we should focus on the education system.
We are.
We should promote that.
Should promote, okay, yeah, you're right.
This is our
You're right, yeah, okay.
We are not a school. I mean, education, further education is private school, higher school, etc. I don't know if it is higher, a lot of university. Research, and I think that our research in the sustainability has given us, this is what people see outside, it has given us a very good improvement, as I said before. But the internal things we do for sustainable campus,
we have to show.
This is not at all visible outside.
Mm-hmm. Yes.
Yes.
Yes. Yeah.
It seems like you've been able to do like really great work in campus. Like, how did you facilitate that relationship and being able to implement different systems? There's a lot of logistics.
It is a lot of logistics, actually. Yes. The most important thing that we started to do is to include energy meters in the area of the campuses, so as to see how much energy each building consumes. So this was the first part, and then we have started other solutions, but it is very, very difficult. Very difficult.
Even just adding energy meters, electricity meters, is a big endeavor.
Yeah. It is a huge one, because other universities have sustainability offices of 10 or 15 people. So yes, well, we love our work. So all together we can improve it and include this strategy to all to all schools. Yeah.
If I can follow on that, how do these activities interface with the Green Tech Challenge?
They are actually, Green Tech Challenge is one initiative that has already started a few years ago, but we have included it in our strategy plan. Also, Research Friday, which is it is organized every year, the last Friday of September of every year. So together with schools, with other universities, we exchange ideas on sustainability and on research. So these are actions that we have already included them in our strategy plan.
I think that's great because I mean, one of the challenges a lot of particularly business concepts have is finding a pilot site. So we had a company that students were starting looking at trash sorting. They wanted to make a system that was commercial where you hold up the trash and then it tells you where to put it. And they struggled so on campus would be impossible. And they wound up doing it
it's huge.
And once they found a pilot, then they fixed all the problems. And I think that's very, it's great that the students have access to that.
It is great, it is. Okay, thank you very much again.
Oops. Okay, thank you. It's the last presentation, so I promise to be brief, very brief. And
you were the last to give the title, that's why.
And to be honest, what my group does is relatively marginal to the general topic these days, but the byproducts of what we do may be very applicable. So, I'm Paul Sotiriadis. My group is the Circuits and Systems Group, and I'm the director of the Electronics Laboratory. Today I will present some of our work that relates to smart aerial surveillance and wildfire suppression. What happened? This is an old picture of my group. We have a relatively large group. I'm somewhere here. And, oops, next one. We are part of the electronics laboratory. I deliberately put the slide to make a connection with Columbia University. The lab was established by a former Columbia professor, Christos Chalkias, Then it was reformed by another Columbia professor, Yannis Tsividis. Then it was run for several years by a Columbia graduate, and I broke the sequence as the last director of the lab. And of course, we are part of the electrical and computer engineering department. We are located somewhere here. The department is the largest one in the university with many brilliant students. So what my group does is circuits, integrated circuits, design, analog mixed signal, CAD tools, especially based on machine learning algorithms, circuits analysis and optimization, and also some more applied stuff which relate to sensors, measurements, and instrumentation in general, systems level design and analysis and optimization. So today I will present 3 projects. One is completed, the other 2 are ongoing. All 3 of them are privately funded. The first one has also some state money. And they relate to surveillance and wildfire management. So the first one is a drone that we built around 2016, 2017, in collaboration with the Naval Academy and 2 other companies. Surprisingly, they don't show here, which was a modular surveillance UAV. The name was Architas. You could disassemble it and put it in a bag, go to the location you want, assemble it, and it could vertically take off and have an area, a surveillance area of about 50 kilometers with a payload of about 60 kilograms. Very advanced telecommunication systems. It could be used to establish a broadband network with base stations on the ground, airplanes, emergency vehicles, and so on, and provide real-time, very high-resolution images, video actually. It could go up to 5 kilometers high and with speeds of about 100 kilometers, and it was very robust in windy conditions. The drone has been used in several occasions, and it has a very high definition camera. Actually, the camera itself was a very costly part of the system. Thermal, one version, and multispectral in another version of the drone. And the drone had embedded AI capabilities for multi-sensor image fusion, object identification, and some decision capabilities, decision support actually capabilities for the operation that it was assigned. Here you see an infrared image and an image from the control center of the drone. I switch topics. I present another project which is in progress, a project which is in collaboration with Professor Nikos Chronis from the Chemical Engineering Department here at the NTUA. And since we had experience with the drones, we said, why sending an expensive drone in a risky situation? It's very easy to lose it and waste 100,000 euros. So why don't we try instead to build something very small, low cost, and basically disposable, like a capsule. And we came up with the idea of smart flare. So instead of firing a flare, you can fire something like a flare, but this something includes all the electronics necessary for surveillance. So the idea is that, let's build a smart flare for aerial surveillance. You fire it, it follows a trajectory, and when it reaches the desirable GPS coordinates or the top height of the trajectory, it opens up a parachute and goes down, transmitting the image of the area. And then you forget about it. So the important is that you get the information fast and don't worry about getting a drone back or losing it. So we started with a flare and replaced all the internal parts with electronics, which includes pretty much the telecommunication system, wireless, a GPU to do all the processing and actually some image recognition, of course, GPS and other variants to track the location, and other sensors like pressure sensor, humidity sensors, and so on. The optics and the camera. And all this had to be built in a very mechanically robust structure to survive in very high G when you fire it. About 1600 G with a maximum of 3000 G acceleration. And you also have some support blocks. I mean, you need a battery, you need a controller to make sure that the battery is passivated when this reaches the ground and does not cause any further problems. So this is how we expect it to work. We have some preliminary study for now. We have images like that. And the processing includes some feature extraction and object identification to track, to automatically track people, fire, or other objects in an emergent situation. Several challenges. Maximum acceleration is not a joke, definitely. Image stabilization and orientation is not trivial. You don't have much control, so you have to do everything electronically. And of course, you always have the trade-off between doing the computation on board and consume power for the computation, or consume a lot of power to transmit the data and do the image processing and feature extraction on the ground. And of course, we hit for about 3,000 meter range, an altitude of about half a kilometer, and we calculated a descent time of about 1 minute. We are in the process of advancing the device, so we'll have more results soon. This is the last project I wanted to mention, and this is a collaboration with different partners. Drone Force is the driving partner. Vantage Towers is a very important partner. NTUA, of course, the National Defense General Staff, and the municipality of Pedeli, and the Hellenic Navy as well, along with Demokritos. So the idea here is to build an as automated as possible UAV that can be used for forest wildfire management and do that at the beginning. So when you have the first flames, be there as soon as possible and take care of that. So the drones are actually expected to be located in cell phone towers. That's why we collaborated with Vantage Towers, a company that handles most of the wireless cell phone towers in the country. So the idea is to intervene as early as possible and suppress the fires at the initial stages, address escalated fires, especially firebrands, have a swift response to fire sites and fast, and basically be the first line of defense operating 24/7. My lab is responsible for the robotic and electromechanical systems for the automated battery replacement, refilling of the drone with the fire extinguisher fluid, and also the electromechanical systems for the containers that release the drone. This is a picture from the first demo. It does not show well, but doesn't show very well, but this is the drone. It's relatively large. It can have a payload of up to 25 kilos. This is the box containing the fire extinguisher liquid. And this is the channel through which it emits the liquid to the fire. So that's it pretty much. Just a basic idea. Thank you. Thank you.
About technologies, ICT from having the fires and climate change effects. So, are there any questions?
Give me 1 second. Let me add that we have worked a lot with sensors, sensor networks, wireless systems, blah, 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 things that can be used for fire prediction and fire identification, let's say. But I think that these are now common technology that you can find in the market. I mean, things like that are probably more future-looking. Please.
Are you participating in the X Prize for wildfires?
No.
Because what you're doing is exactly what this prize.
It's a very good idea. This project is a very new one, actually. It's in progress, and I definitely make a note.
I'm not sure. I just opened to see. I couldn't find what the deadline was like, but it's essentially identification of a fire technician using drones or some other kind of airborne device, and then suppression of the fire. It's $11 million price.
Not bad. Thank you for pointing out.
Any other question? Yes.
Just a clarification question. Is Athens the same one?
No. They stole the name. We started it in 2016. Yeah, same name. And this was started by 2016 by a former PhD student of mine who was a commander in the Greek Navy.
That relates to my another question actually. The flare, which is a very interesting idea, is actually close to the concept of sonobuoys, if I'm correct, in the sense that they are throwing sonobuoys from the seas. There are sonars that actually trying to locate this, and they're transmitting all the information back to the helicopter or to the. So that would be an idea, for example, to have a drone above and find or throw these flares, not wait for somebody from the ground to throw the flares, but to have like a drone, another drone, should have a couple of flares, and whenever they understand that it's an area, throw for more detailed information.
You are right, and actually we have a variation of the concept where we throw something like a rocket with compressed air. It goes up and it releases several capsules, each one like the one I described. But the rocket-like thing with the compressed air is not that cheap, so you have to recover it. But you forget about the little pods that you drop. So it's somewhere in the middle.
From my understanding that at least in the media, they ask Greeks feel a little bit better about likely height, either neighboring country or drone to drone. But apparently we have a lot of know-how, and it has not been not presented to the general public. We feel that we are likely to be high, but apparently we are not. And we saw, for example, in the Zografou system, that actually out of the blue we had the system that actually work. And apparently we have drone technology. But I was impressed that you said that this back in 2016, which was brought back with actually very high technology.
Exactly. Actually, it happened that last week I was there with the director of the lab discussing about the cadavers and possible collaborations, and they have done an excellent job.
Any other question?
I just want to mention something that also for our colleagues of Colombia, that NTUA can participate in ONR projects and AOR projects. They have visited us. We have actually one ONR project. So have it in mind in case you can collaborate possible collaborations.
Any other? Thank you very much.
Thank you very much.